The first thing I'm going to go over is the fact that once in a while you fellas may need to put some kind of a voltage out to test something on a car other than direct 12 volts. You have to put out some type of a voltage reference into something, and people say, how the heck do I do this if I don't have some sort of a sensor simulator or something like that? All right? So you might have to put out a 5-volt reference signal, an 8-volt on some vehicle, 9-volt on some signals, all right? Or a direct 12 volts, other than when the car is charging and going to 14, it may need an exact 12 volts, all right? You need to have something that will give you a varying voltage, all right? So what I put for you here, and it's in your handout, all right, with part numbers, all right, with a part number on here. If you go to a place like Radio Shack or some other electronics house, all right, you'll find an LM117 is a variable voltage regulator. You have to put a control circuit in to make it that way, but the diagram is here, and it's in your book, all right? The diagram is here to make that a variable voltage regulator, all right? And that's with using a resistor and a variable resistor, all right? And what I'm going to say is you may have to change this one and fiddle with it a little bit, but that's what the book recommends for most applications, all right? And if you do put a voltage input of anywhere from 9 to 16 volts going in, now this system will handle more. You could put a 24-volt battery or whatever up to it, all right? But if you put in between 9 and 16 volts, all right, 9 volts minimum, 16 volts, you can get output of as low as 2 volts. And if you have at least 16 volts going in, you can get out of it up to 15 volts. So you can get your 5 volts, your 8 volts, your 9 volts, your 12 volts, no problem, just by varying that little resistor there, all right? So you can put that circuit together yourself and make yourself a little variable voltage supply, all right? All right, let's go right away with a problem, all right? I'm going to hit you guys with things today before everybody gets a little tired later on. All right, I'm going to hit you with things right away that are the more complicated things, all right? I had a 2010 Chevy van. Was anybody here online and was on when we did the last round table? Nobody here? All right. I brought this up during the round table. I had this problem on a car. It's a 2010 Chevy van. It charges only for about 30 seconds when you start it up, and then stops charging. If you turn the lights on, it'll activate the charging again for maybe 10 seconds, 15 seconds or so, and then again stop charging. If you bring the RPM anywhere above 15, around or above 1500 RPM, it'll start charging normal. But don't drop that RPM, otherwise it's not going to charge anymore. This is the complaint from the shop. The vehicle was at about 3 or 4 shops, all right? And this was the complaint from the shop. Now, what was done to the vehicle from this shop and other shops? The alternator was replaced 2 times with a brand new Delco alternator. The alternator was swapped with a like vehicle. This was a fleet vehicle. They had 100 of these vehicles. All the same. They had 100 of these vehicles. They swapped the alternator, figuring it was still an alternator problem. The vehicle with the problem still had the problem. The vehicle that did not have the problem had no problem. The PCM was reprogrammed. Then it was replaced. Then that one was programmed again, and then they said, well, you know, this thing can have a BCM interaction with the PCM, so let's reprogram the BCM. So they did all this programming, still nothing. Then they called me to take a look at it. And I'm saying, well, I've got to get something more than information that I normally have on this vehicle, because this thing's got to be really, really involved. So what I did is I went into, I got a hold of the Delco rep, I got a hold of one of the voltage regulator manufacturers that manufacture them for rebuilders and everything. I got a hold of quite a few people involved in all these computer-controlled alternators. And I got a pretty good earful from them about how this thing really works and the quirks, a few quirks on them, and what happens in there. But let's get into the system, computer-controlled charging. All right, I'm going to go over to GM system. I'm going to show you a little about the Ford, a little about the Chrysler, and tell you that basically they're almost the same type of system. All right, but let's start off with, everybody's looking at a lab scope. If you have your lab scope on a vehicle, on the wire from power to ground, and you turn you turn a switch on. You turn a switch, anything on, you should see the rise, all right, to whatever the voltage is, and stay on for as long as you have the switch on, and then when you turn, as soon as you turn the switch off, boom, it drops right out. Right? If you do 2 pulses, you go on, off, there you have 2 pulses. The on pulse for the length, the length of time that you have that on is the duty cycle. The on time is the duty cycle. All right? The on time compared with the off time between, so that's on time to the next on time, including the on and off, is the pulse width. That's 1 cycle. And the cycles per second is hertz. Now, if everybody knows what a chopper circuit is, a chopper circuit, they used to use chopper circuits on outboard motors. That's where one of the things they came out with to control DC motors, and they used to use those a lot before they started using them on the cars. Right? They'd use them on outboard motors and electric outboard motors, you know, like trolling motors. Right? And what that is that's just turning the system on and off, but doing it very fast. So what they do, if you're running at full speed, you may be turning it on and off and giving you maybe a 98% duty cycle. So it's on 90% of each pulse. All right? If they want to slow it down a little bit, they may turn it on only 75% of the time. If they want to slow it down more, they may turn it on only 50% of the time. And you want to troll real slow, they may turn it down to pulse it only 10% of the time. But they do it a lot of times, all right, at a higher frequency. If we have, for example, if we have 4 pulses within 1 second, we have 4 hertz. So if you're running 60 hertz, it's 60 times in 1 second. All right. Now what the PCM does is the PCM gives a 90 to 95% pulse width modulation at 128 hertz, 128 times a second. All right. Gives a pulse width, so 128 pulses per second. And each pulse width, if it's going to turn the voltage regulator on fully, it's going to give a 90 to 95% duty cycle all right, to the voltage regulator for about 20 seconds or so after start. Let's remember, I just told you what happens when you start the vehicle. It charges for about 30 seconds, 20, 30 seconds. All right? So then I'm saying, well, gee, well, that's normal right there. All right? Didn't think that was normal before, but now I do. Right? Now I do. It'll also tell the voltage regulator to go fully on when there's a low voltage situation, if it senses a low voltage situation, or very high loads, like when the radiator fans come on full. All right? Something like that, rear window defogger goes on. Something's drawing a heavy load. All right? Now, again, at 128 hertz, it can turn on the voltage regulator, 95%, 70%, 50%, 10%. It can turn that regulator on and off. And the percentage of time the voltage regulator, that's, you know, the duty cycle that it's using, is that percentage is the percentage of time the voltage regulator is being turned on. If it's being turned during each cycle, all right, and if you take 95% of that cycle, it's on, that voltage regulator is on most of the time. If you look back here, all right, that's at 128 hertz. It's putting about 5 volts into the voltage regulator to turn it on. The output, now there's 2 wires on this alternator, an input, all right, to command it on, and the output for the PCM to detect what's going on inside the alternator. So the output of the alternator goes back to the PCM. When I say the output, I'm not talking about the main output that goes to the battery. I'm talking about the sense output. All right, feedback. All right, we'll go with that, and I'll get into that later when I show you the 2 wires that come out of the alternator. All right, and what's happening here is the signal back to the PCM, all right, can match the other signal if the regulator is not in full control. And the only time the regulator is in full control is when the PCM tells it, gives it 95% control or 95, 98% control, whatever it is. All right, that's the only time the voltage regulator is in full control. Other than that, the PCM will cut it down. But whatever happens, the alternator signal is actually what you see, the alternator pulsing the field circuit to ground. This is the amount of pulses that you'll see, and it's done at 400 hertz. So it's monitoring how much field current the voltage, or how much time the field is on, all right, at 400 hertz. That's the signal it's sending out. If you take a look at this, you'll see 400 hertz and 228 hertz. The PCM puts out a signal of at 128 hertz, about 5 volts. The alternator puts out a signal about close to battery voltage at 400 hertz. So if the PCM puts out one signal that's full, in the same amount of time, they're talking about almost a 3-to-1 ratio. So by the time the PCM puts out 1 pulse, the PCM is going to put out 3 pulses. Alternator, excuse me, is going to put out 3 pulses. PCM can put out 1 pulse. The alternator will put out 3 pulses. All right. So if the PCM puts out 1 pulse, and it wants to see what the alternator is doing, it'll watch the alternator, and you'll see those 3 pulses. If it goes low, if the pulses are short, it may see 3 short pulses. Right? All I'm telling you is that the alternator puts out one set of pulses at different pulse widths, all right? Doesn't change frequency, all right, or height, all right, or voltage. The voltage is the same, all right? What it does is the pulse width, the length of time, all right? And basically, all it's doing is telling the voltage regulator what to do, how long to stay on. The voltage regulator, in turn, will tell the PCM how much it's controlling that field circuit, and it's just feeding it back to the PCM. Now, if the PCM is giving full 90 or 95% pulses to the alternator, all right, as the maximum duty cycle, the voltage regulator will have control of the voltage. What if it gives you this signal, it's telling the voltage regulator, you're on all the time, you're controlling the voltage. Again, it's doing it at 128 hertz. All right? The voltage regulator, if it needs to charge fully, if the battery's low, it's going to send a signal back, again, at close to battery voltage, all right? And at 400 hertz, it'll send the signal back to the back to the PCM, all right, that it's charging full. It's grounding that field most of the time. All right. Almost full fielding the alternator. Doesn't have to, though. If the voltage regulator sees the voltage is going high and the load is because the load is getting lower, the battery is getting charged, so the voltage is starting to go high, it itself can control the voltage just like a voltage regulator normally does by reducing the field. When it reduces the field current, it's just doing it by shutting it on and off in smaller pulse widths. All right? Does everybody understand that part of it?
Are you basically saying that there's no regulator in this alternator?
No, there is a regulator. Oh, yeah. And like I said, either the PCM is telling the voltage regulator inside the alternator, all right, at this point, I'm just telling you, it's telling the voltage regulator to stay on fully. You've got control of the voltage. You've got voltage control. All right? The voltage regulator can control the voltage by itself. All right? Just like any voltage regulator. If you turn the voltage regulator on, it'll control the voltage by itself. And it's doing it, some older cars, they may not do it with a pulse width modulation. All right? They may just they'll do it by some other regulation. All right, but these are doing it by pulse width modulation, and all it's doing is sending the signal back to the PCM and telling it how much it's controlling it. Now the PCM can say, all right, I'm telling you to go on, you've got control, but boy, you're really getting down. If you're only putting small spikes in there, that means that there's very low, that means the voltage is high, is charging normal, but there's no load on the car. So at that point, the PCM can say, hey, if there's no load, we don't have to charge that high. So again, that's doing it at 400 hertz coming out of the alternator. All right. The PCM can turn around and say, hey, you're going down, you're dropping down to a low pulse width. You're dropping down to a low pulse width. Therefore, there's not much of a load out there. So why do we have to keep the battery charging at 14 point something volts and keep that load on that alternator? Why does it have to stay up there? That battery is really charged. All right? So let's drop the voltage down some. All right? So what it can do is it can put a pulse, and it can actually turn the voltage regulator off, on and off. All right? So it can regulate the signal going into the regulator and say it's not going to charge as much. So actually the voltage can start coming down. It can regulate the voltage. The computer can control it by turning the voltage regulator on and off at 128 hertz. So it's very fast. All right? Now, are we going to use a lab? Now, technically, a lot of this stuff that I went over right here isn't going to create a drastic amount of problems unless you have a real nasty problem with the car. Because you're seeing there's still voltage there. It's just the fact that it's at different pulse widths. All right? Your multimeter, for example, is just going to average voltage out. If you really need to see square waves, you've got to get a lab scope out. Do you really need to see the square waves? In most cases, you don't. Well, we're not going to use a lab scope unless we really need to. We're going to use a multimeter and just check some voltages. All right? Here's the alternator with the two wires on GM, L and F. All right? The L terminal is the terminal that the PCM uses to tell the alternator whether to charge or how much to charge, and to tell the voltage regulator not only how much to turn it on and off, but tell the voltage regulator whether it's going to go to hold whether it's got control of the voltage or the PCM's controlling the voltage. Now, the first thing to do on these vehicles is to check voltage drop. How can you check voltage drop on this type of on an alternator, main power wire and ground, if it's not charging? And yet you say, well, but that's the first thing you've got to do is check voltage drop, because GM says voltage drops on these things create all kinds of problems to the case of the alternator and to the main power terminal on the alternator, the big, heavy, charge wire on the alternator. They said it's the biggest problem on these cars. And if you have a problem and you want to check voltage drop, how can you check voltage drop unless you've got a load on it and there's current flowing? Because if there's no current flowing, you're not going to be able to check voltage drop unless you use some sort of a load circuit or something and you actually load the wire. But the way to do it on these things, and of course to check the system, is get your scan tool out and activate the field. All right? If you activate the field with the scan tool and the alternator charges, you know that, one, the alternator can control it, and the PCM can control the alternator. The PCM can control the voltage regulator, and the voltage regulator can control the alternator. You know you've got control. And then you can also do a voltage drop test, because it's going to command it to charge fully when it commands it to charge. So you go out there and you do your voltage drop test. All right? Now, if it can't command it, then you know you've got a problem there. You've either got a PCM problem, another wiring problem, or whatever. All right? But you've got, at that point, you're going to be able to determine whether you're going to have control of that alternator. Yes?
Rich, you said about 1,500 RPM.
I'll get over that. I'll get over that. All right? I'll tell you that in a minute. All right? All right? You can do that. All right? But right now you're going to check for control, whether that PCM can control the alternator. All right? Because that other function is not a function of the computer. It's a function of the alternator and voltage regulator. All right, so you want to check and see if your PCM can control that alternator. All right? The L terminal should have about 5 volts on it when it's being told to charge, especially when it's being told to charge fully. Should have about 5 volts on it. All right? The only time it's not is in a no charge situation, just like the older vehicles with a generator light. The generator light has battery to one side of it, goes through the bulb, and goes to the L terminal on the alternator, and it goes to ground when it's not charging. And there's a diode trio inside the older alternators, and when you've got positive going through the alternator, through the bulb, into the alternator to ground, through the alternator, and when the older alternator started to charge, a back voltage would come out of the alternator, all right, through the diode trio. It would come out, but the voltage coming the other way, and you're not going to ground anymore. You've got positive against positive, okay? So it turns the light out. All right? These don't work that way. They will give a ground. They will give a ground of a specific resistance to that wire when it's not charging, but when it does charge, there's no positive voltage going back the other way. All it does is change the resistance of it. Just switches the resistance of it so that the incoming voltage from the PCM can still control it. All right? It's just changing. It doesn't have power shooting back the other way. All right? I'm just giving you how it works so you can understand what's going on with it. All right? When you're testing. All right? So the only time you'll get, if you turn the key on without it running, that PCM is going to try to put a pulsed 5 volts to it, but you'll see the voltage very low because it's being grounded out. But as soon as it starts up, you should see the voltage start climbing up to 5 volts. All right? And it's telling it to charge. Any questions on that? And the other wire, the F wire, the field terminal wire, is the feedback that goes out at 400, and you'll see voltage on that too, as long as it's charging. You'll see voltage on that. And that's going to be higher voltage. All right? There's 3 things that this does. They don't, all these alternators, not every alternator does it. You may have to check the specific manual of the vehicle, the service manual. All right? But some have soft start. Soft start is the fact that when you start the vehicle, it brings the alternator online slowly. All right? It starts to charge slowly and brings the voltage up slowly. All right? That's soft start. Then they have gradual load response. Some of them. All right? Gradual load response is you're driving down the road, you're charging. Doesn't matter what you're charging at, but let's say you're charging at 13 volts. Maybe even less. Maybe 12 point something volts. There's no load on the car. All of a sudden, the radiator fans kick in. The radiator fans kick in and all of a sudden instantly draw 30 amps or so. Now, instead of the alternator instantly responding to that and pushing out 30 amps and loading right away, what it does is, again, it brings the load in gradually. It brings the voltage up gradually to compensate for the load. So it doesn't just shock the system. All right? And self-excitation. That's where your question comes in on the self-excitation, all right, can happen. And again, they don't all have it. Some do. The actual spec on self-excitation is about 26 to 2800 RPM. But that's not engine RPM, that's alternator RPM because it's an alternator spec. All right? So when I got the spec on this thing originally, it said the alternator should self-excite at 2800 RPM. And I'm saying, well, why is it doing it at 1500 RPM? And I had to remember, I said, well, of course, because I didn't realize at first they were talking about alternator RPM. I'm thinking they were talking about engine RPM. All right? You have to remember something, depending on the pulley sizes, all right, will depend on the RPM differential between the alternator and the engine. Anything up to this point? Any questions? All right. Here's the Ford plug on the Ford alternator. Yes?
You didn't say what the actual solution was for that charging system.
The charging system? All right. I would have gone over, I'll tell you, but I would have gone over it when I finished the alternator section. All right. But you want it now. All right. All right. It was a reprogramming problem. Okay. They programmed it I don't know how many times. All right. And here's the key, because this is, like I said, this is why I was going to go over it later. When these computer-controlled systems are reprogrammed, they ask many questions. And GM told me, for example, you get one question wrong if you're not sure of it. One question can throw everything off. All right? Yeah. Yeah. That too. All right? Now listen. All right? And here is the key to this, what happened in this solution. All right? What happened was one of the questions in programming said, is it a 2-wire voltage regulator or is it a 4-wire voltage regulator? All right? And naturally, you look, let me just go back. I would have showed you that later, but let me go back. And what happened?
I went all the way back.
There we go. I went all the way back. No, I didn't. Okay? All right? Naturally, you look at the voltage regulator, and there's 2 wires coming out. Say it's a 2-wire voltage regulator. All right? But
Two internal connections.
That's not
what?
the actual
No.
voltage regulator.
Well, that's the connector to the voltage regulator. That is the connector right at the voltage regulator. All right? They're all 4-cavity. That's correct. All right? What they want you to do is pull the plug and look at the voltage regulator. Inside, you'll either see 2 pins or 4 pins, even if they don't have 4 wires on it.
They're not utilizing it.
All right? They're not utilizing it. But yet the question says, is it 2-wire or 4-wire? Yeah. Okay. That's on the PCM reprogramming, correct. PCM,
The
correct.
question should be, is it 2-terminal or 4-terminal regulator?
That's it.
That's what the question is.
It should be, yeah, differently, right, right.
The school would have gotten the programming right in the first place.
That's what happened. It's the entire thing was reprogrammed wrong multiple times.
Well, why do you think it actually had to be reprogrammed? What the hell happened in the very beginning? What happened?
From what I understand, all right, there was a aftermarket items put on the vehicle, all right, and I know I found problems in this vehicle, and every problem that I found, I said, you know, could be a problem. I said, but I know there's a problem with the vehicle. I found somebody put, I don't know if you've ever seen them or not, these heavy-duty 100 amp circuit breakers that they put on the aftermarket accessories, all right? They actually put one in the starter circuit. And then down where the B plus cable went down to the starter, they cut the wire and then tapped a wire off to go to the back of the vehicle.
Stereo amp.
No, this was a commercial thing. It was a commercial vehicle. All right. So but yet that I think it was 150 amp circuit breaker was actually in the starter circuit.
So who was the blow? The problem started.
So, and there was all kinds of problems. That had to be high resistance in the circuit, all right? And I found a bunch of problems, and every one I fixed, I said, well, maybe it'll take care of it. And it didn't. It didn't. And I did say to him, I says, you still got, I think, a programming problem. And he said, but we reprogrammed it. And I told him, and that's when I told him, I said, some of these vehicles have current sensors in the line. Actually, according to the VIN number on this particular vehicle, it was supposed to have a current sensor. It did not, and neither did any of the other vehicles. And when I called Delco on it, he said, that's odd. I said, but it was a fleet vehicle. On fleet vehicles, anything goes. Anything goes. All right? Okay? So it may not make sense, but on fleet vehicles, anything can go. All right? They're also trying to save money on the fleet vehicles. All right? In any case, that's what the problem was, and they even reprogrammed those the BCM because that current sensor reads and transmits its signal to the BCM, not to the PCM, if you have a current sensor in there.
Do you know if the original alternator had two prongs?
The old alternator?
The original one, off the bottom.
No, they all had, every alternator that was on the car had 4 prongs on the voltage regulator, but was programmed as a 2-wire, okay, regulator.
Were there any codes or lights on?
Were there any codes? No. It's just a weird charging problem. Just a weird charging problem. All right? Here's the Ford. Now, Ford and the Chrysler works very, very similar. There's almost no difference. You're still just want to check for voltages, really. You can put a scope on it if you want. They all work at different frequencies, and they're all pulse width modulated. All right? But, again, you can just check for your voltages, make sure they're there. Ford has a sense terminal for B+, which is the terminal number 3. They have the monitor, just like the F terminal. It monitors the field, how much the voltage regulator is turning the field on and off. And it has the command, just like the L terminal on the GM has a command. All right? Now, I'm going to tell you something. I didn't have a story to tell yesterday or the day before, but I'll have a story to tell you today because I did one of these today with a charging problem on a Navigator. And I went there and I checked this out, and it would charge. It would charge, but it would throw all the lights on in the car. When I say the lights, all the warning lights, the computer was throwing all kinds of stuff out, all right? And it was charging at a nominal rate. It wasn't charging right, all right? The computer wiring, I was getting a signal in, I was getting a signal out, and I was saying, what the heck is going on? Well, they have a sense wire here, the 3. That B+ sense wire, that's not the B+ output wire. That's just a sense wire to sense voltages, to sense the voltage. It goes to a fuse or a fuse link, depending on the vehicle. Some type of a fuse. Right? That wire had less than a volt on it. It's supposed to have battery voltage. All right. I went into the vehicle and I found that in the power distribution box, the fuse was at 1 volt. I looked at power distribution wiring diagram and found it gets power directly from the bus coming in, and there were 5 or 6 other fuses, even more, on the same bus. And every one of those fuses had power except this fuse. And I said, that's ridiculous. All right? But when I looked at everything very closely, I found that some water must have gotten into this fuse box. All right? Because I saw corrosion. Not very heavy, light corrosion. All right? And this was from a used car lot. Somebody traded this vehicle in because they had problems. All right? What did I do getting into bypassing things? What did I do? I took an inline fuse holder, put the proper size fuse on it, in it, and at the power distribution block, I took that fuse out, I put it into the fuse holder, all right, and I went to the main connection terminal that supplies all those fuses with power, and I put that inline fuse holder right to the block, all right. The wire was good. I traced that out, all right. Once I put that fuse holder in right at the block, all right, I had 12 volts on there. Everything came back online. Everything was perfect. No more codes, no more lights coming on, blinking on the dashboard. Everything was fine. So that sense wire is very critical. All right? And like I said, I couldn't tell this story yesterday in Massachusetts or yesterday in Connecticut or the night before in Massachusetts. I did tell them about that wire, and I did say that if you get high resistance in that wire, you can have problems. But now I have an actual story to tell, and it can happen today. Yes?
Rich, you think if that wire was open,
Right.
no voltage there whatsoever?
No voltage?
No, say there was no voltage on that wire.
Right.
Would it overcharge?
No. It's going to actually go into a default mode. All right, as long as one of two things happen, either the PCM is going to turn it on into a default mode, or it's going to, if it has a fault where it's self-excitation mode above so many RPMs, it'll come in to the same thing, to a specific fault voltage. All right, and then, but it'll start. But it will charge. It will charge some. It will charge some. All right. All right. And Chrysler products. Oh, sorry. There's two of the voltage regulators that they use. Actually, there's a lot of different ones. Some of them require you to measure resistances on all three of these to ground, and they should be above 10,000 ohms each, all right? But the most popular problem with some of them is that this particular, the number one terminal right here, all right? If you have a no charge condition or a problem, all right, you measure the resistance to ground from that terminal. Now this is on the alternator now itself, from the number one terminal to ground, all right? And it should be between 1.2 and 1.6 ohms. And if it's not, that regulator is no good. And you guys aren't going to replace regulators. Only the rebuilders usually would do that, all right? But that means for you, you'd have to replace the alternator, all right? Now last night we had a fella from an auto electric shop, and they do their own rebuilding there too. And he was familiar with all of that, all right? They do that, all right? Chrysler products have, their plug is just a two-prong plug, all right? Again, control and sense, all right? Same thing, all right? The rebuilders, when they do rebuild these things, you think they check frequencies and everything? Yeah, right. No way. Most of the yeah, spray can, right? Most of the rebuilders have an excitation plug that when they run on a test bench, they plug this in, activate, and the alternator activates. All they want to make sure is the alternator has the capability of charging and the voltage regulator set point is right. All right? They plug it in, turn it on, watch it run up. That's fine. It's out the door. Now this fellow who was here last night, up there in Connecticut, he showed me a machine that he uses, and it does actually give him there's a frequency, and he can make it so that he sees the square wave coming out. He can get a diagram of that. He says, but he usually just makes sure there's voltage coming out, voltage going in. Of course, he's putting voltage going in to activate it, making sure there's voltage coming out on the terminal feeding the PCM, feeding back to the PCM.
That's why he was in the class.
And that's what he was in. He wanted to check.
Does the thing right.
Oh yeah, yeah. All right, okay. But most of them don't. I've talked to several of them, and they say, I don't know. All I do is plug the plug in, run it up, it charges, it goes in the box, and that's it. And most of the time, you may not have a problem because if it's activated, it's activated. All right. And the set point is the voltage regulator. It's done at the factory. All right. There's no adjustment on that. All right. Battery drains. Let's get into battery drains. No more questions on the charging systems? All right. Let's get into battery drains. I do battery drains all the time. I've been doing battery drains forever. What I hate is when shops call me and say, I got a drain in the car. Can you come out and do this drain? Find what's causing the battery to drain down. The battery's going dead overnight. And the older cars never had any problem. But started to get the cars with the computers, and they started to give me some problems because of the timers in these cars. Right. And some of these cars would take like an hour to time out, especially in the mid-90s, especially 96 and up, 95, 96, 97, even up to 2000. You get an hour to time out on a car. All right. Now, if I walk into a shop and I prep a car, which takes a couple of minutes, prep a car, and then have to sit down for an hour to wait for this car to time out, that's kind of ridiculous. So I got my shops, now most of them, to prep the car for me so that I can come out and do it because they don't want to pay me that extra hour for wait for the car to time out. Now granted, some cars take 10 minutes to time out. Most cars today take less than a half an hour to time out. But there are vehicles out there that take up to an hour to time out. There are some newer cars that take longer. For example, Volvo and Volkswagen, all right, have certain timeouts up to 4 hours. However, within a half an hour or less, they will time out to such a low amount that you wouldn't really even consider it a drain. Unless they're using a time back where they're doing tests. They'll shut down and time out, all right, and you won't see any drain, but all of a sudden they'll re-energize themselves, come on, do a test, and then go back off, and it's done.
You're saying like an evap test.
Like an evap test, exactly. Exactly. All right? So, so in any case, I have these guys do a preliminary setup for me so I can come out and do battery drain tests on the car for them. All right? And here's a battery drain chart. And when I get a lot of people, a lot of shops say to me, well, you know, I got a guy with a battery drain. It goes dead if the car sits for 3 or 4 days just sitting, the battery goes dead. But the guy uses it at least every 5th day. So I need a little bit more, you know, let's not fix the car. We just want to get a little bit more time out of it. So I'm going to give you, I'm going to give the guy a bigger battery, more cold crank amps, all right? And I turn around and I say, why would you give the guy more cold crank amps? What you really need is more reserve capacity, the capacity to handle these low drains. Cold crank amps just gives you more amperage available for a split second or a few seconds to start the car. It has no effect on the reserve capacity of the battery. Now, if you look at Interstate and if you buy a battery from a parts store or whatever, Interstate, if you have their catalog, will tell you the reserve capacity of each battery. All right. If you're buying it from a parts store or whatever, you'd have to ask them. They do have it in their catalog, of their battery catalog. All right? But you have to ask them what the reserve capacity of the battery is. Now, most automotive batteries run usually between 80 minutes reserve capacity and 120 minutes reserve capacity. All right. But here's the thing. If you take a battery that's 550 cold crank amps, take the same size battery, the same, the same warranty battery, same period of warranty, things like this here, and you say, I want to go from, God bless you, from 550 cold crank amps, I want to give this guy, because of a battery drain, I want to give this guy 1,000 cold crank amp battery. That'll take care of it. No, it won't, because a lot of times when you increase the cold crank amps of the battery, the reserve capacity goes down. So you're actually defeating your purpose. You're actually defeating your purpose. So don't use the reserve capacity, the cold crank amps, to determine the reserve capacity of the battery. All right? And this is just a chart for you that can tell you, that tells you with a drain, with small drains, I'm not talking about something, an amp or 2 or 3 or 4 amps, all right, milliamps, all right. This would be, your top scale up here is your meter reading, all right, depending on which scale you have your meter on, all right, and the reserve capacity of the battery and how many days, all right, at that amperage would take before the battery goes dead. All right, and you can see that at 300 milliamps, all right, a fully charged brand new battery, all right, fully charged, may only last 2.8 days. All right, and a lot of batteries that are out there, when they get to that point that you're thinking about a battery drain, that battery's already maybe has some damage to it already. It's already getting a little, it may not be fully charged, so you could get 1 day out of it. All right? So we're talking about brand new stuff here. The gray area. The gray area is overwork area. Now what that means is that, let's say a battery has an 80-minute reserve capacity battery has a 100 milliamp drain on it. All right, it should last, again, if it was brand new, but 10 days. But the guy uses the car every day or every other day. He never realizes there's even a drain on the car because that car doesn't get down to the point, a critical point, where it's not going to affect the starting of the car or the cranking of the car. But it is affecting the battery. What's happening is that battery is now what they call cycling. It's deep cycling. It's drawing down and up, charge down and up, all right? And it's cycling more than it would if it was just cranking a car and then being charged right back up, all right? It's cycling. Deep cycle batteries like boat batteries or outboard motor batteries, things like that, all right? They're meant to deep cycle because their plates are designed for it. Car batteries are designed for cold crank amps. They're not designed for deep cycling. They're designed to put out that high amps for cranking. That's what they're designed for. All right? So cycling, all right, can cause premature failure on the batteries. But it can also cause premature failure on alternators, because what is the alternator doing? Every time this thing gets drawn down, it's got to keep charging up again. So it's, especially in the hot weather and everything, all right, it's got to keep charging this battery all the time. A lot more amperage than normal, all right? And of course your economy can go down because of it, all right? But this is why whenever you change a battery, or you change an alternator for any reason, always do a parasitic draw test to make sure there's no draw on the car. All right? All right. Now, I spoke before about doing a prep before you do a battery drain. Testing for a drain and or locating the source of the draw. All right? The first thing you're going to do is access the battery. Very first thing. And all the fuse blocks, relay blocks, everything. You want to get at all the electrical panels. All right? You're going to test the battery. If you need to, charge the battery and retest the battery. You're going to start the vehicle to activate everything. When you start the vehicle, check for starter draw. Check your starter. And you're going to check the charging system. Now, checking for your starter and your battery, you can also use the test that I gave you the last class, where the battery's sitting there, 12.6, you know it's fully charged. There's no amperage coming out of it right now. All right? You're using an amp clamp on the starter and a voltmeter on the battery. The voltmeter's set to min-max because that's going to give you, it's going to read that thing faster than you can read it. It's going to lock in on the highest or the lowest setting. All right? And then you crank the car a few times. All right? Even to starting. Doesn't make any difference. Crank it to start several times. All right? All right, let's say you see at the starter, may go up to 240 amps, whatever. All right? If it's normal amperage. All right? You see battery voltage, looks normal. Crank it again. Crank it a couple of times. All right? You see the battery go down a little bit. Say, it's on the borderline now, maybe. All right? Especially only at 240 amps. All right? See it go down low like that? You got a battery problem. If you've got steady amperage around steady amperage at the starter, all right, and it's normal, all right, and you see voltage dropping down, you've got a battery or connection problem. All right? Most likely a battery problem. All right? Yes?
On some of the newer testers, one of the slots in there, goes through the whole system.
Right.
Initial voltage.
Initial voltage, right.
A lot of that causes like the ABS light to come on because it drops below the threshold.
Oh, yeah.
So that's one of the features in like one of the snap lights. You pay for it.
Oh, yeah. Yeah, oh, yeah. Absolutely, absolutely. You watch that. That's why when I say if you put min-max on your meter, all right, it'll lock in. It'll lock to that first crank. All right, fast. If you can watch the display on your meter, all right, and you may not see it go that low, but that meter saw it go, and when you put your min-max to minimum voltage, what did it see? All right, in a maybe 100 millisecond window, the lowest voltage it saw, you may see it go down. All right? And you don't have to have super expensive equipment. You've got it with your multimeter as long as you have a min-max on your multimeter and you have an amp, something to clamp on for your amperage. All right? An amp clamp of some sort. All right? Now, let's say, again, you're back up. Your crank the first time is 240 amps. You're back up. That all looks fine. Your second crank or third crank or whatever, all of a sudden, your amperage goes nuts, but your battery voltage is hanging in there pretty good. All right, you may have a polling problem inside of your starter. All right, you may have some kind of a polling problem or something. All right, you have a starter problem, not a battery problem. All right, just going over what we went over the last time. All right, now getting back to neutralizing things. You actually, what you did is you accessed everything. The cars all open up. Now you have to neutralize everything. Neutralize, what does that mean? All right? All your doors, your hood, your trunk, any light switches, any pin switches, anything that's telling that computer that the doors or the hood or the trunk or anything are open. The computers want to see the car closed up. So what do you have to do? You have to latch the doors. All right. For the imported cars where they have the in the door pillars, they have the switches in the door pillars. All right. They have a Phillips head screw in there. All right. Just take the screw out. You don't have to take the switch out. The screw is the ground. You take the screw out, you're done. All right. If it's an older car and they have pin switches in the A pillars or whatever, and they screw in, see if you can pull the wires off the back or whatever. All right. But just you have to neutralize that car. All right. They do have a spring clamp of some sort that's available to put in there and actually hold those switches closed. I think it's a spring clip and a magnetic holder or something. I have seen at one of my shops, I saw someone have that. All right? But you do have to neutralize the car. Neutralize all your access points. All right? Now the computer thinks the car's closed up, everything can go to sleep. All right? So now you have to wait for everything to time out. That's where your waiting time is. One thing you can do while you wait is you can look, see if there's any lights on. Remember, the car's all opened up. See if there's anything you can see that's on or whatever. All right? And you can listen. I've heard fuel pumps running. I've heard vacuum pumps, auxiliary vacuum pumps. I've heard computers. Remember I told you that different things run at different frequencies? They're putting these pulse width modulated signals out at different frequencies, high frequencies. You can hear this. You can listen. All right? Listen by the computers. If you hear a high-pitched sound, if your ears are good enough, all right? But if you hear a high-pitched sound, and I hear it myself, even at my age, all right? And I hear things myself, and I say, there's a computer or something that's staying on. Now, it doesn't mean, if you listen right away and the car's not timed out, you may hear that. After timeout, it may go away. All right, that's why you really have to let it time out. All right, but if you can actually see someone left a light switch on, or I'll tell you some of the things that I find that are really, really interesting, all right? Somebody grabs, especially on GM cars, they grab the rear view mirror, all right, to adjust it, or to go to the night mode, for the back, for headlights coming up on you and from the back, and you go to flip the switch or whatever. There's some of them, there's two map lights underneath, and they hit that switch, and a lot of times they never see that switch on. They never see that light on. All right? I found, you know how many of them I've found? They'll hit that switch and nobody ever sees it on because they're not really that bright. All right? I've seen.
Lights are the people.
Yeah, the people.
Yeah. Right. Okay. Maybe both. All right. So in any case, all right. Your vanity lights, another big thing, because a lot of times the sun visors are up and you can't see the lights on. All right, vanity lights. All right, I see them on. All right, and things like this. All right, you can look for things like that. Now, while it does, if we're using a non-interruptive test, we don't have to interrupt the system, so therefore we don't have to put this non-interruptive test into the car until the vehicle times out, or at least we give it enough time to time out. All right? Now, when it times out, or we give it enough time to time out, we're going to hook up the test equipment, and we're going to use either an inductive meter, like an inductive ammeter, any type of an inductive meter that's going to be able to give you your milliamp range, down in the milliamp range, or we're going to use what they call a parallel circuit system. All right? Now, let's go to the parallel circuit system, because remember, we're also going to have to look for latched drains. And that's the reason why we use non-interruptive test. A latched drain is something that goes on. Let's say you start the car up, a relay cuts in, the computer's got a relay cut in, all right, and the engine is running, or this relay keeps some power on somewhere. You shut the key off, it's supposed to go off, it never shuts off. Could be due to a leaky diode or something, could be anything, all right? That's a latch drain. What happens if you disconnect the battery to put a meter in? And I got guys tell me all the time. They'll say to me, I got a drain in the car. Okay, and it's a heavy drain. How do you know it's a heavy drain? Well, the test light's very light, very, very heavy, very bright. Or I'll say, I'll say, well, how do you know it's a heavy drain? Because the voltmeter says I have a full 12 volts. All right? Or a guy will say to me, once in a while, he'll say to me, yes, I have a 3-amp draw. I love 3-4 amp draws because those you usually find very quickly. They're not these little milliamp draws. If you have a 3-amp draw on a car, 4-amp draw on a car, give me an idea. What do you think might cause a 3 or 4 amp draw on a car? A couple of people hit it at once there.
A door that's open.
A door that's open? Yeah, but then the lights would be on and you'd see that, all right? Something that you wouldn't see. Alternator field, absolutely. Trunk light wouldn't be 3 or 4 amps usually. Radio amp sometimes, yeah, it could draw up that much there, okay? A latched relay, yeah, a latched relay, if there was enough out there, all right, like a fuel pump, okay, with a relay that's latched, absolutely, absolutely, all right? So usually on something like that, I'd go out there and no problem. Sometimes I would even say to him, all right, if you're sure that there's that much of a drain, don't worry about prepping the car. I'll find that drain. There's no problem. All right? But that's a latch drain. All right? Now, I'm going to give you a little story that I told these other fellows. I'm going back a few years ago. A company asked me to help them do a test on their techs. All right? And we went to the manager of each of these retail stores, all right, service stores, and the departments, and we went to each manager's car, all right, one at a time, and we took the manager's car and we put a latched drain in their car under the dashboard. All right. We went in. The manager said to the guys, his techs, he said, guys, get together if you want. But do me a favor, will you please look at my car? I have a drain in the car. It's draining the battery overnight. They went to their techs. They let their techs go through the car. At the end of the day, the guy says, what'd you find? Did you get anything? And he said, everybody came back with the same answer. In every one of the 30 or 33 stores, whatever it was, they all came back with the same answer. At the end of the day, there's no drain in the car. All right? Now, without doing anything else, without telling anybody anything, they redid the test. Several days later, the manager came in and said, guys, you know, my battery's still going dead. Give it another shot. The same exact results. Not one technician came back and said, yeah, we found there's a drain in the car. Why was that? They took the battery off and put a meter in. Once you disconnect that battery, that latch drain cuts out. It will not cut back in unless you start the car. And if you've got a meter or a test light in between the battery post and the battery cable, how can you start the car? Okay? All right? So you do a non-interruptive test. That's why we do it. All right? Then you're going to... Now, the non-interruptive test, I'm going to show you the non-interruptive test right now, the one, the parallel circuit that you can use if you don't have an amp clamp. All right? It's in your book right there. All you're doing is taking a jumper pack, all right? You're hooking it up positive to the positive side of the battery, the negative through your amp meter through the 10 amp port on your amp meter, through the amp meter to ground. Now you've just paralleled the system, right? You just paralleled the system. And when you do parallel the system, you're going to check, because of the amp meter that's in the system, all right? You're not just taking your jumper pack, grounding the jumper pack somewhere, all right, and putting the positive to positive somewhere, all right? If you put that multimeter in there, when you hook it up, you're going to get a reading. The reason why you're going to get a reading is because this battery is never going to be equal to that battery in voltage. All right? The thing is that if you do get a reading on that meter, that's what you want, because now you know you're connected. If you just connect a jumper pack somewhere and you don't have a good connection and you disconnect your battery, you've lost everything. But with using the meter, if you've got current flow, that means you're connected. The only reason why you're not going to get a current flow is, one, you've got a bad connection, you've got a blown fuse in your meter, all right, or a very rare response, and I do get this once in a while, once in a blue moon. This battery and this battery are absolutely identical in voltage. So you got 12.2 volts and 12.2 volts, and that meter isn't going to budge, all right? But all you have to do to check and make sure that that's, because you haven't disconnected anything, all right? All you have to do to make sure that you've got a connection is turn the headlights on in the car. If you get a reading then, you're connected, because then it's going to draw from both batteries if you're connected, all right? So you will get a reading, all right? I did a class. I like to do these classes directly for shops. When I do this, parasitic draw class is the most popular class I have. All right, and I go into shops and I do these parasitic draw classes. All right, hands-on, and I use their equipment. I said, get your multimeter out, get your jumper pack out, get your amp clamp out, whatever. Let's do the test on the car. And we went and we did this test in one shop one time. The guy had 5 of his techs, and the head tech came over. He says, all right, I got the best equipment. I'm going to go on the car. We'll use my stuff. I said, oh, let's use your stuff. He hooks it up. He's got no reading. And he says, I have no reading. I said, all right, well, let me do a test. So I did a little test, and I said, your fuse is blown in your meter. He says, can't be. My meter works. I says, yeah, your meter works on everything but amperage. All right, it's a separate fuse. All right? So I said, all right, definitely blown. I did a check on it, and I showed him the test. I used the test light. I showed him the test, and he says, I guess. I said, well, either that or your meter's completely shot. He says, oh, that better not be. I said, well, your fuse is blown. All right, so naturally, instantly, a couple of the other guys said, well, I'll give you a meter. I'll use my meter. We went through 5 meters. Every one of them, and every one of the fuse was blown. And why was it? I had to get my meter off the truck and do the test. All right? Every one the fuse was blown, and why was that? Because they didn't hook it up wrong. All right?
The leads in the amp side when then they test voltage later.
Absolutely. They left the leads in the amp test, and then they went to do a voltage test. They turned the meter to voltage, but they put the leads across the battery, and they were in the amp. So they were putting direct battery voltage, positive, negative, just blew the fuse instantly.
Most of them feed, but it's in the wall hole.
Yeah. Yeah, some of them do. Yeah. Yeah. Some of them do. All right. But not all of them. All right. The more expensive ones may do that. All right. But a lot of the meters don't. All right. And you blow that fuse, and
How is it you're not popping the fuse in the meter here?
how come you're not popping the fuse in the meter? Because you're just paralleling the battery. All right? You're not in series. Right. You're paralleling the battery. Okay? And then, once you parallel that battery, all right, once you take your negative side off of this battery, all right, now you're feeding the vehicle through the jumper pack, but you're only feeding whatever amperage is draining, that's all. And that meter will read the exact amount of amperage that you're drawing at that point. All right? Now you use this method also with that test if you're going to change the battery as a memory saver. Same thing. All right? You can make sure you're connected. You don't have to worry about going into the cigarette lighter or something else, or a burnt fuse in the car or something like that. If you're using the OBD2 connector and something like that, you've got to make sure that this thing is going to work. You use your meter. The only thing you're going to do different is when you hook this up to a ground here, instead of hooking this up, if you're going to change the battery, all right, and use this as a memory saver, all right, you don't hook it up right at the cable. You hook this up to another positive source in the car. Could be the back of the alternator or whatever. All right, another constant battery source. All right, then you can remove both cables. Just be careful of the positive battery cable because it's still live. All right, because if you touch that to ground, it's going to blow the fuse in the meter, and then you're going to lose everything. All right, and all your memories. All right, but just disconnect it, clean them, put the new battery, take that battery out, put the new battery in, reconnect. You're good. And while you're doing that as a memory saver, all right, just to use that to save the memory when you're changing a battery, once you disconnect that battery, you'll automatically see if there's a drain in the car. All right, as long as the car is still closed up and everything. All right? Getting back to, we did all of that. Then you're going to measure, again, your draw. Now this time you're going to wait for cycling drains. A cycling drain is something like something that's powered up all the time, like a power seat. All right? Power seat motors. A lot of people get in and out of cars, and as they get in and out of cars, they slide off the seat, and they break their power seat switch motors. Power seat switch. All right? They break the switches, or they lock them down. All right? And they stay on. And what'll happen, it'll draw for a while, and the circuit breaker inside the motor will heat up, and then it'll pop, and there's no draw. And eventually, when it cools down, it'll click back in. You got to draw until it heats up, and it goes off. That's a cycling draw. The most popular one is antenna motors and seat motors. All right? The most popular ones are seat motors and antenna motors. That's a cycle. So you're going to wait for cycling drains. That means just looking to see. All right? And that's this. I just put this in there, and we're waiting for that cycling drain to come. All right? Now you've got to determine whether you got a heavy drain, a light drain, a cycling drain. All right? Or whether you don't have any drain at all. Now, if you don't have any drain at this point, if it times out and there's no drain, chances are you may not have, one of two things. Either you may not have done that starter and battery test to begin with. All right, you may have skipped that test just to try to get to the drain. Maybe you should go back and do that test. Or there's an intermittent drain in the car, which is usually something that's caused by the driver of the car. All right? It could be that they park the car on a specific angle, or they getting out of the car, they do certain things. I found, one guy told me the other day, he found that the person certain days leave the key in the car when they put it in the garage. And if it's parked outside, they take the key out. And every time he puts the car in the garage, the battery goes dead. All right? Well, of course, the key was in the car. It wasn't on, but the key was in the car, and it kept systems active. All right? All right. Now we're going to isolate the circuit. Now you want to find where this drain is, where it's coming from. All right? Now we've got to go to the fuse panels. In the fuse panels, or the fuse boxes, we have things, we have the bigger fuses, like the maxi fuses, ATMs, the smaller ones are ATMs, you got ATCs, you got the maxi fuses, you got FLFs, all the fusible links, FLFs, FLTs, all these other fusible links. But most of the larger high amp fuses feed the smaller fuses. all right, in most cases. So the first thing we were going to go to are the smaller fuses, the ATCs and the ATMs. All right. You've also got in the cars, you've got circuit breakers, and you've got PTCTs, positive temperature coefficient thermistors. All right, and these are thermistor current reducers or current circuit protectors. All right. Now, most cases you're not going to find problems in PTCT circuits. A lot of them are circuits that only are active when the key is on. Most of them don't have battery power to them. Circuit breakers can have battery power to them, all right? And most of the circuit breakers that they use in cars today are modified reset breakers. Those are the ones that push into the fuse block, all right? And they're called modified reset because what they do is, unlike the old circuit breakers that just, again, the circuit breakers in the motors, they go click on, they click off. They click on, they click off if there's a short. All right? But these circuit breakers, what they do is, if there's an overload or an actual short on the circuit, they thermally open up, and as soon as they open up, there's a little heater inside that, if there's still a short on the circuit, that little heater starts heating up and keeps the circuit breaker from closing again until the load goes away or the short goes away. All right? And what happens is that thing will get hot as anything. You can burn your hand on it. All right? But it draws anywhere from about 200 to 300 milliamps. And that 200 to 300 milliamps will give you quite a drain. So those things, you can test them very easily by getting close to them, feeling if they're warm, okay? Just be careful. Don't really touch them if they've been sitting for a while in a blown state, because they will get really, really hot. You'll burn the living daylights out of your hand, out of your fingers, all right? So just to talk about those, you've got to find where the short is then. You've got to pull them out of there and trace the short, find out where the short circuit is, all right? We're talking about the ATC fuses and ATM fuses, the most of the popular fuses that are used on the cars today, all right? First thing you're going to use is, believe it or not, a test light. Why do we use a test light? No load. Forget load. Forget load, all right? The only thing we use a test light for is, before the next step, we're just going to use a test light to determine what fuses have power. If I've got 3 fuses in this fuse block that have power, just by testing bing, 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 I got 3 that have power, and I've got 12 fuses in that fuse box, all right? Why do I have to go through testing every circuit? All I need to do is test the 3 circuits that have power, right? So I just take a test light and I say, okay, this fuse has power, this fuse has power, and that fuse has power. Good, those are the only 3 I'm testing, because the others don't have power on them. All right? Nothing can draw. They don't have power. Then you're going to take a multimeter and you're going to put it on the millivolt scale. You take your multimeter and you put it on your millivolt scale. Now, when you take your meter and you put it on the millivolt scale, you'll notice something. The meter starts wandering like crazy. You hold that meter up near fluorescent lights, near different things, it'll go nuts. It's looking for voltages. It's looking, and it's seeing everything around it, all right? But if you take those 2 tips of your multimeter and you touch them together, what's going to happen? The meter's going to go to 0. It's going to zero out. You take the meter and you put it across a piece of steel, a piece of copper, a piece of anything that has virtually no resistance in it, all right? It's going to zero out. Whether you touch it or you touch that to both ends to something like a piece of steel or whatever. If you put it on a fuse, all right, that's just sitting there, okay, it's zero out. Even if the fuse has power on it and there's no current going through it, it'll zero out. However, if there's any current going through that fuse at all, it will not zero out. It'll give you a reading. I don't care what the reading is. Now, there are charts out there that can actually tell you, and the chart, a page is about this thick if you go through them all, because it tells you all kinds of fuses, it gives you all kinds of readings, and it depends on whether it's this type of fuse or that type of fuse, and this amperage fuse and that amperage fuse, and everything else. It doesn't make any difference. All you're concerned about, if it goes to zero, there's no draw at all on that fuse. And if it doesn't go to zero, there's a draw on that fuse. One thing to be careful of. If you don't have it connected real good, this means you have to have real good sharp tips on those probes that you've got. All right? And make sure you have good connections, good probes, good connections to your multimeter. All right? That's why you always test it ahead of time. All right? And make sure the tips are very thin, very sharp. Very thin at the end, very sharp. All right? Because you want to dig into there and make a good connection. Because if you don't have a good connection, it'll just wander. If you see it just wandering, you don't have a good connection. It's going to go either to zero or it's going to give you a specific reading. If it wanders, you just don't have a good connection. All right? And if it has any kind of a reading at all that's not wandering, you've got a draw, with one exception. If it goes overload, all right, you've found a fuse that's blown. All right, because you're reading from one side of the fuse on 12 volts, the other, and you're way over scale on the meter. All right, you're way over scale on the meter. If you go overload, you've probably got a blown fuse. Check it. Use your test light again and just check it and make sure. All right, okay? Any questions on what we've done there? Yeah?
Everything you've said so far, you never said that to pull any fuse out of the box.
Never. Don't pull fuses. You're not pulling fuses anymore. Non-interruptive. Every test we're doing now is non-interruptive. How many times have you ever pulled a fuse out of the car and actually seen the amperage go up the drain? Absolutely. Because there are circuits out there that, computer circuits, that have to be activated in order to hold and shut everything down. Okay? So why would you start pulling fuses? And then sometimes you pull a fuse out, maybe you don't even see anything. You go to put the fuse back in and poof, everything goes nuts. All right? That's disturbing the circuit. You don't want to disturb the circuits. Yes?
Just clarifying, we're doing this test with the car battery disconnected and the jumper pack hooked up through the amp meter?
Once you've, you can, all right, but listen, once you've done the parallel and found out how much draw you have, and if you have a draw, you can reconnect the battery again. It doesn't make any difference what battery you're using, all right? All right? It's just the fact that you just want to make sure that you're still powered up, you're still doing it powered up, so that you can test for a draw. Doesn't matter whether you're using the jumper pack or the car battery, or both. You can hook the car battery back up again. Doesn't make any difference. And then when you later on when you check the car, you're going to do the original test back again just to see if you have a draw. And the easiest thing, of course, to do is just use an amp clamp, because now you don't have to disconnect the battery at all or hook up a parallel circuit. All right? All right? Any other questions? Yeah.
And this is with the doors disabled.
Disabled, absolutely. That's why you have to disable the doors, because you've got to go around the car, you've got to go to the different fuses, inside the car, outside the car. Sometimes they're in the trunk, sometimes they're under the seat. All right? That's why you neutralize all your access points. All right? Any other questions on it? Now, once you've isolated a fuse, you say, hey, this fuse is drawing power. I've got a reading on my millivolt meter. All right? I have a millivolt reading on my meter. This circuit's drawing power right here. Now you can go and you can look at the wiring diagram. Now from the wiring diagram, the power distribution diagram, you say, okay, well look, that fuse goes out to 3 different things out there. Who knows what they are, all right, at this time, depending on the car. It may go to 1 thing, 2, 3, 4, 5 different things, all right? For all intents and purposes right now, I've put 3 different things that it's going to go to out there. Several things you can do at this point, all right? You could go out there to each of those things and unplug it, all right, and see if the drain goes away. You could put an ammeter, an inductive amp meter, find the power wire, the wire that comes out of here, at each one, at the connector, all right, and just clamp on that one wire and see if it's, and remember, you have to clamp just on that wire because you may have the power wire going in and it may, and the ground coming out, and if you clamp on both, remember the meter's going to measure the power in this direction and the power in that direction, and it'll cancel out. You'll get no reading, okay? You have to go just on the power wire going in, the same wire that's coming from that fuse, all right? Clamp on it and see if you have a reading, if that's what your draw is. Yeah?
Those 3 things that you're going to, and you're testing, would you unplug it and leave it unplugged?
If you unplug it,
Leave it unplugged?
all right, yeah, oh yeah, you unplug it, all right, and then you see if your reading went down.
Don't plug it back in.
You don't have to plug it back in right away. You know what I mean? You can plug it back in later if you want, all right, if you found that that's what the problem is. But I'm going to give...
That's not the problem, but would you plug it back in or
If it's not the problem, if it's not the problem. If it's not the problem, you can temporarily leave it unplugged, yeah. Absolutely.
You don't want to plug it back in and wake it back up.
Right, you don't want to wake things back up. You can leave it unplugged, yeah. Once you unplug it.
Otherwise, use the amp clamp.
That's what I'm saying. The amp clamp, these amp clamps are fantastic today. All right, these little amp clamps. I use it all the time. All right, every half of the shops that I go to have already told me next time you get some in, I want one. All right, and that's everybody tells me the same thing. All right, these amp clamps, they're $139. It's very, 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 very inexpensive, and they work fantastic. That's all I use. All right. Now, any questions up to this point? All right. Let's say these things are 3 modules out there that it goes to. You say, well, gee, if I disconnect this module, is it going to ensure that let's say I disconnect the BCM. If I disconnect the BCM and it goes away, have I found the problem? Is the BCM the problem? Not necessarily. That's right. Not necessarily. All right? Because the BCM may, over communication bus, be telling a different module to go on. All right? Or something may be telling that BCM through the communication bus. One of the other modules may be telling that BCM that something's live or whatever. All right? But the biggest problem is voltage problem. All right? As you can see, most of these, they'll have a battery lead coming in, and this is what your drain would be on the battery lead. All right? This is where your drain would be, on that battery lead from that fuse. All right? But a lot of these modules may either have an ignition or accessory lead to activate it, which may come through a fuse or a fused circuit, or they have a bus line coming in from another computer. All right? So this computer may be on, but this computer may be the bad one, because this is telling this one to come on. All right? Let's tell you how to check for that. All right? You could say this one may be the one that's drawing power. You may clamp it right here and say, oh, that's the one that's drawing power. All right? So that one's bad. But it may not be bad. This computer may be telling it to turn on. But that computer may not be bad either. This is the main problem. Corrosion. A lot of this causes problems in the car. Voltage leaks. All right? Voltage leaks. Now, You go to your fuses that are not powered up, that normally are powered up through the ignition or a relay. Okay? Not battery-powered fuses. And you go to another fuse block, or you go to the fuse blocks, and you find out the fuses that don't have power. All right? With a test light, you can test it and make sure this one doesn't have power, this one doesn't have power. All right? But just testing it with a test light doesn't mean anything. You have to test it with a voltmeter. Your computers are designed to go off from anything below 1 volt. If it has accessory or ignition power to it, if the voltage drops below, when you shut the key off or whatever, if its voltage drops below 1 volt, that computer is supposed to shut down. Now, if you ask me, all right, if a circuit's supposed to be off, all right, it shouldn't even go to 1 volt. It should be 0. All right? But for all intents and purposes, the actual computer's specifications on a lot of these things say as long as it's below 1 volt. All right? But if I saw on a circuit, all right, to ground, and I'm measuring a circuit like that there, and I see a volt, I still think there's something wrong there. There's got to be corrosion starting. This could cause an intermittent problem. Maybe sometimes it's 1 volt now, or just below a volt. All right? And maybe sometimes it's 2 volts. All right? So you at this point, you can take and you can measure the other fuses and see if you have any voltage on them. Because if that voltage doesn't drop out, that computer can still think it's on. It will never time out. It'll never time out. Find a lot of problems like this. All right? A lot of problems. All right? Especially cars with a lot of computers in them. All right? But it's a process of elimination. And it can be done relatively simply, all right, by just going through your process. You find out, you don't have to check every fuse, all right. Find that if you look at these things and there's only at these computers, all right, if there's only 1 fuse going to 1 computer, check that fuse. You don't have to check all of them. Check the fuse that's activating the same circuits and modules that the drain is on. You've found what fuses the drain is on. Now, you may find a drain on a couple of different fuses. All right, start with 1 and work that circuit out, because chances are that you may find that that those other fuses feed into other modules that are related also. Any questions? Everybody back in? All right, so we've gone over this. Any questions up to that point? There's an alternative method of testing for draws, and that's using infrared diagnostics. Using an infrared scanner. The prep is about the same. You do have to open up everything on the car, and sometimes even more, because you may want to pull the panels down under the dashboard so that you can see under the dashboard. Panels down from the sides of the trunk if there's modules back there. You want to look at these things. That's if you have to, all right? But most of the time I find things right out in the open with an infrared scan tool, all right? The only thing different about an infrared scan tool is that you do have to do a little extra prep, and that's, first of all, you're going to have to use a battery tender on the battery, because you've usually got to let that vehicle sit for a while. You want to let that vehicle sit with the battery on a tender, not a regular battery charger that's cooking that battery, all right? You may want to let that vehicle sit in your shop overnight. Because what you want to do is you want to stabilize the temperature of that vehicle. Remember, you're looking for temperature. If that car's been out in the sun all day, or even for a little while, you're going to have big temperature differences in the car, and you may not be able to tell what's going on. You want that vehicle to stabilize. The only thing you want getting hot is what's drawing power. All right? So if you've really got a problem, you can't find some other way, all right, and it's definitely drawing power, and you can still see you have a draw, all right, what you do is, again, you let this vehicle sit in a temperature-stable environment, stabilize the temperature of the vehicle, and go through the car with a thermal imager. You'll pick up things like this here. That's a typical thermal image picture. All right? You'll see that they give you a lot of information on the screen. And this is just the least expensive one out there, the one that's really designed to do close-up stuff on cars and equipment. All right? And you could see on the temperature scale on the bottom, the lowest temperature in here, in this picture, is 88 degrees Fahrenheit. That's usually, it looks like it's somewhere up, that's the vehicle chassis, the body of the vehicle. All right? And the highest temperature is 230 degrees. That's over the boiling point of water. You get burnt pretty well on that. All right? So in other words, and in the bullseye, in here in the center of that picture, the average temperature is 229 degrees Fahrenheit. All right? That happens to be an auxiliary water pump on a Mercedes. All right? Auxiliary water pump on a Mercedes. All right? Sits down by the driver's side wheel, inner fender there, inner wheel well. All right? And that's what I found on that car. Now, you're not necessarily going to say, hey, the water pump is bad. You might have to say, all right, well, what's keeping that water pump on? All right? But you've at least got a direction. Now you know what's drawing the power. It could be a latch drain. Maybe the relay's stuck. All right? Or module or whatever. Okay? But you, just by opening up the hood, all right, as long as the vehicle's stable, the engine wasn't running, I got so much heat under there you can't see what the heck is going on, all right? The vehicle is stable. Everything is off. And that's why I say that on something like that, really you want to keep, you'd rather have a battery tender or something on there so that it's just keeping the battery stable, all right? Keeping a charge and keeping everything on. You don't want to disturb that, all right? Another thing, this thing you'll recognize right away, rear defogger, all right? Found that just by scanning outside of the vehicle. I didn't have to do much of anything else, all right? You'll find things like this right away with a thermal imager, all right? You'll find things with a thermal imager. You'll find, for example, a fuel injector that's running hotter than the others. Maybe it's drawing more power. All right? If it's running hotter than the rest of them, you could be drawing more power, yes.
On the fire department side of things, that's how we find fires in the walls.
Absolutely. Absolutely.
You can measure the heat in the wall.
That's right. And if you see a rectangular portion on the wall, and it's cool on this side, cool on that side, there may be two walls in there on the other side of that wall. And right there, where that wall is, all right, that wall is hot. There's a room, there's a fire on, or something that's causing a lot of heat on the other side of that wall. And if you see a line here and a line there, there may be a room on either side of it. But you could say that it's definitely something behind there. All right? You can isolate specific areas. All right? The only thing, I didn't mention this because it just dawned on me though, but just to tell you, because you brought that up, all right, if you're looking through a window, all right, thermal imagers do not see through glass. They'll tell you the temperature of the glass that's there, all right. If you think you're going to see something through the window, you're not. You're going to see the window, the temperature of the window. Remember, you're not looking at visible light or anything. You're looking at a thermal image of, you know, what's directly in front of you. All right? The surface, that's correct. Surface temperature. All right? Therefore, is another thing. If you're under a dashboard, or here, you're standing next to the car, all right, and the glass is there, all right, you'll see the glass. But if you're standing there and you're pointing the thermal imager at the car, you'll see your reflection, thermal reflection in the glass, all right? If you're under a car and there's a shiny spot, something that's reflective under the dashboard, a vacuum actuator, something that's shiny and usually metallic or shiny, all right? And you go into the car and you look and you say, oh, there's a hot spot there. That may not be an actual hot spot, all right? Look and see what it is. It may be just reflecting your body heat back to the camera, all right? All right? There's little quirks that you'll find, but basically you find stuff like this stuff all the time with a thermal camera, all right? And again, you can pick out an ignition coil. One might be running hotter than the other, drawing more power, or whatever, all right? An injector, anything like that, all right?
How about an infrared temperature gun? Would you consider that viable?
On certain things, you're not going to find...
Each injector, you might find...
Yeah, if you can get one, you got to remember something. An ejector's fairly small. You'd have to really get up close, all right? Even the ones with the lasers on them, all right? Even the ones with the lasers on them, you think you're getting a reading right where that laser is, okay? If you're standing 2 feet away, all right, you have to look at the circle, right, because it's a cone shaped out, all right, and there's a degree. You buy these things, all right, according to the circular, the degree of angle, right, as it goes out, all right. So you may, in order to get an injector that's a 1/2 an inch wide or 3/4 of an inch wide, you may have to be 2 inches away from it to get your reading.
Most of them you can get pretty close to.
Yeah, a lot of them you can. A lot of them you can. A lot of them you can. All right. There's a good, for some things like that. All right. But if you want to see an actual image and compare an image, you use the thermal imager. All right. Let's get into some wire repairs. I do wiring repairs all the time. Have a no power problem. I go in, the guy tells me, he says, I got a circuit, an open circuit problem in the middle of a wire harness. I can't find where it is. It's open, I know it is, but it's good on both ends. All right? So, the best thing to do is just cut it on this end, cut it on that end, and run a wire between the two. All right? Bypass it. All right? There's problems with that. There's the broken wire the guy called me for. All right? There's the broken wire. All right? I found where it was because I traced it with a wire tracer, and I found where the broken wire was. All right? The problem is that where there's one problem, there's usually other problems. All right? And if you look at this, you'll see there was crossed wires over here. There was a couple other rubs in there, different things, all right, that were causing other problems. And as far as the guy was concerned, he was saying, well, as long as I just run a wire from here to there, that'll fix the problem. But it could cause other problems. All right? It can create other problems. Not only that, when you do these things here, you may find things like splices in the middle of the wiring harness that you never knew was there, and you ran a wire around a splice. Now, yeah, you've got one thing working, but now something else isn't working. You've got splices, you've got other things, and a lot of times this happens just corrosion or a meltdown or something heating up. Doesn't make any difference, all right? You've got breaks in the system, you've got to find exactly what's going on. Same thing with shorts. You find exactly what's going on. All right? Don't just bypass things like that. All right? Melted wires, harnesses like this here, that's melted pretty good. I've done these things. All right? I've fixed these things all the time. harnesses like this, where the wires are all melted in there like that. But I tell the shops, I said, I need access to these wires. If you want me to do something, I need access. I see these, even connectors like this, and I think I told you this the last class that I had. I said fixing the connector, something similar to this. All right, is rather than attempting to get the whole plug, which in most cases you can't, you look at the rest of the connectors. They all seem to be good. You've got one bad one in there. All right, cut the darn thing off, pull it out, clean that area out with a Dremel or something like that there. Clean it out so that a good female end terminal of the proper size will fit in there, a universal one, all right? And take a new terminal, crimp one onto a wire, the proper size wire, cut this terminal back here, pull it out. Put the other terminal in, let it stick out this far, put it in so the wire goes through to the other side where you can connect it. Connect it up, and then when you want to put the connector back together, the connector that's sticking out over here, put that on the other end first. And then just slide the rest of the connector on, and it'll just pull back up into there. All right? Don't try to put it in there and then put the whole connector on. Put that terminal on, and put that terminal on the other end of the connector first. And then just slide the rest of the connectors on. It'll just slide right over the wire, all right, and over that terminal. I told you. I tell all my accounts, if I'm going to do wiring, I want it exposed. If it's a dashboard harness, I want it exposed. I want the dash off. I want the kick panels off. If the wiring harness runs behind the emergency brake, the foot brake, the emergency brake, I want that off. I want everything cleared out. I want total access to that harness. And I don't mind sitting there and working on that harness then. I'll slit that entire harness open, and I'll repair that harness.
How many times do I have to tell the customer to do that? This is the actual problem in the area where they took it apart.
The problem? Well, I'm saying, I don't know where, you have to find out where the problem is, and that's what we're going over here, okay? You have to find what started the problem, all right? But if the wiring harness is burnt through the, all the way through the harness, you have to access that whole harness, all right? But yes, you do have to find, when you're doing it, what caused the problem. You want to find the end that shorted out, or whatever, and why did it take out the harness? Who put the 30 amp fuse where the 10 amp is supposed to be? Or put a 30 amp breaker in place of a 20 amp fuse? Or something like this, okay? Or, I don't have a picture of it this time, I did have a picture of it the last time. Who took the 20 or the 30 amp fuse and because it kept blowing, wrapped wire around the two terminals, all right? Wrapped wire a few times, copper wire, and stuck it back in there. Who did that? Tinfoil. Tinfoil around the old fuses. I haven't seen it around the new fuses. But I've seen the new fuses with wire, wire wrapped around, 10, 20 times a wire and then stuffed back in. All right? So, in any case, the one thing you have to do if you're doing repairs like this here is when you split the harness open, all right, all the involved melted copper, just the copper, I'm not talking about the insulation, but all that melted copper has to be removed. Every bit of it. All right? You have to replace it. And, of course, as I said, check for splices or anything else that's in line. And what I usually do, I work a section at a time, maybe a foot or 2 feet at a time. All right? That copper, when it heats up, it bubbles that plastic up. God bless you. It bubbles the plastic up. I'll go in a section at a time, maybe a foot or so at a time, and I'll find the copper burnt. I'll dig it out. I'll cut it. And on the other end, where it's cut, I'll take it and take it with a pair of pliers, and I'll slowly and make sure it just pulls right out. So there's no nothing can touch that wire. And the wire is not even in the harness anymore. The plastic insulation is still there. It may be still melted, but I'm not concerned about that. All right? Because if that copper's not there, it can't touch anything. It can't short out another wire. All right? If it's gone, if it's out of there. All right? If you find it's melted into other wires, if you see the wire itself that it was melted into is fine, but it's just exposed, insulate it with either tape or the liquid tape or something like that. Insulate that, all right? And of course, check for anything that you see that it is crossed. If it really melted into a bunch of wires, separate as much as possible without pulling a lot of, without making a mess. Separate it as much as possible. All right? I'm not concerned about the plastic because the plastic does not conduct electricity. When you're making connections, of course, all the connections on the cars today are welded like this. All right? You can't make connections like that. All right? But you're going to use connectors like good butt connectors. You're going to use AVPs or parallel AVP connectors, where this is what I use all the time, all right, for almost everything, all right, where the wires go in to a single hollow sleeve that has no seam in it, all right, goes into a single solid sleeve, all right. The wires go in over one another like this, and one crimps them together. It's just like a weld. Best way to connect the wires.
What are those called again?
AVPs.
Where do you buy those?
I usually get them, well, a lot of the accounts get them from me, because the only place I used to be able to get them was at the airports. The airport supply, it used to be very expensive, all right? And if you want to go to the airport supply houses and buy them, you can, all right? But again, it's very expensive, all right? I just happened to make a deal and find somebody who was able to supply me, but I have to buy 5,000 of each, 10,000 of each at a time. That's the only way I could do it, all right? So, but I do have them available, all right? I don't know where else to...
For like household, like instead of using the wire nuts, they have something similar to what you're talking about. You slide the thing into like, it looks like a triangle. You slide it into a triangle, both ends of household electrical, and it's doing the similar thing of what you're saying, but it's, instead of using the...
No, well, but that's not a crimp. You don't crimp it. These are crimp terminals, all right? These are crimp terminals. This is what the factories used to use before they welded, and it's the only thing that you can use, all right? Because it's the same. They used to use them before they used welding. Now they use the welding, all right? Those are that he's talking about are terminals more like they just hold by tension. They just hold, right? But I'm talking about using regular crimp terminals. That's the best thing to do, all right?
They have the same style, but they also have the one that you crimp, and they also have heat shrink on them. You take the wires like that, and then you just put them on, then you crimp them.
Oh yeah, well, some have insulation, some have heat shrink.
Right.
Stay away from the ones that have heat shrink and a little pellet inside. You put the wires in and you use a heat gun, all right, and it's supposed to solder them together with low temperature solder. Stay away from those. Doesn't work. I don't believe in soldering on cars at all. There's a reason why they use that. You know, in a household, they use solid wire. Why? Because in a house, the wires don't move. Once they're in, that's it. A car, wires shake, harnesses move. That's why they use stranded wire. All right? Soldering is good for circuit boards, but if you solder a wire, when solder wicks up the wire, all right, due to capillary action, it makes the wire stiff. All right? It doesn't bend anymore. And it makes the wire stiff so that if there's any movement in the wire breaks at the edges of the solder joint. All right? Don't believe in soldering on cars at all. So a guy who sits there and says, hey, I just rewired your car, and I soldered every single connection in the car. Every wire splice I soldered. All right? Don't do it. Don't do it. All right? Use good crimp connectors. Now you can use, now that what I was telling about the AVP connectors, or the aviation grade connectors, all right? Those connectors don't have a seam in them. Most connectors you'll find out there have a seam in them that run along as they're formed. You'll see it's as they form in the die, all right, the seam goes like this. Now, when you're crimping these connectors, all right, most people don't look down the end of the connector and see where the seam is. They put the connector, shove the wire in, and crimp it, no matter what, all right? But that crimper should be up and down on the seam. It could be on the bottom, it could be on the top. But when it's crimped, and I'm talking about right now, I'm talking about an insulated connector, all right? Or if you happen to use the same type of crimper with a non-insulated connector, it doesn't make any difference, but it has to be crimped like this, with the seam in one of the seats, up or down, all right? If you're using what they call a dimple crimper, or a crimper that has a point that comes up into the bottom of it, all right, and puts a dent in it, all right, that's used for non-insulated terminals, all right. They still may have a seam. The seam still has to be in the seat, and the dimple or the stud has to come up opposite that, in the bottom. And most shops that I know of just crimp them any which way, all right? You should not do that. This is the way a crimp is supposed to be done. You want to use heat shrink? Use heat shrink. Don't rely on heat shrinking being waterproof, even if you use heat shrinking with the sealant in it. Double wall heat shrink, all right? Cars use them, manufacturers use double wall heat sink, and they run them outside the car or under the rugs of the car. Water still seeps in and still gets into these things, all right? So don't rely on it to be waterproof. Matter of fact, sometimes I even recommend, especially like outside the car or under the hood, all right, as long as, if you do a crimp in a wire, just make sure it's higher than anything else. Any water that gets in it will just run down, all right? If you have it in the lowest spot, the water will settle in there and cause corrosion, all right? But if you have it higher, all right, it'll turn around and the water will run down and wick away from it, all right? So it won't corrode, all right? Let's talk about radiator fans. I get a lot of people ask me to bypass radiator fans. The problems, I can't get the fan to work no matter what, they say. Or it doesn't come on right, or it's intermittent, or it's this. What can I do to get around it? I can't really get anything going on here. Okay. They make radiator fan switch kits, aftermarket, that can be used on a car very easily. And a lot of these guys will tell me, we'll just turn the fan on with the ignition switch. Anytime the engine's running and the key is on, anytime the key is on, those fans are going to be on. But they're not made to do that. They're made to cycle on and off. They're not made to run continuously. So what we're going to do is put some kind of a kit in. Here's a solid state kit with a relay, all right, has a temperature and a little potentiometer to adjust the temperature you want it to come on at, all right. They always usually have maybe a 10 to 20 degree temperature differential that it'll shut off at, all right. But the turn on is adjustable. Some may even have an adjustable turn off, all right? But there's all kinds of kit. This is solid state. Probe goes into the radiator in between the fins, all right? They have another type, all right? It's just adjustable mechanically, all right? Here's one. They also have, you can buy different temperature range sensors and put them right into the block, all right? These things, through relays, can turn the fan on. If the computer does not have a current recognition circuit that determines that the radiator fan is actually drawing power, all right, If you use these systems on a car, the computer will never know as long as the temperature range is within the normal range of the computer. It'll never know. So if your cars are getting a little older and you've got some problems, all right, you can use something like this. There's no problem. What about AC though? All right, guy says, hey, I got AC too in the car. How am I going to turn the fan on with that and the radiator at the same time, the temperature of the radiator at the same time? All right, they make circuits for this. They even make circuits for, guys say, well, again, we'll just, AC compressor comes on, we'll just run a wire to the relay so that when the AC compressor comes on, the fan comes on. When it goes off, it goes off. If you realize that on most of the cars today, the fan doesn't do that. The fan doesn't go on and off directly with the compressor. It may go on as soon as the compressor goes on, depending on the circuitry. It may go on as soon as the compressor goes on. Some may go on high side pressure, but some go on with the, it's fine if it goes on when the AC compressor goes on, but you can't turn it off when that AC compressor goes off because that high side isn't low enough. It's still got to come down more, all right? But they make timers. They're available. There's a lot of aftermarket stuff that's available. The timers to go into the circuit, all right, that once it goes off, once that AC compressor goes off, you can even have them where you can adjust the time. That it can stay on for 30 seconds or 45 seconds or so after that AC compressor goes off. They make them. They're all available. Guys, I have shops call me all the time and say, what's available to do this? What's available to do that? All right? Can I get some kind of circuit? How can we do this? All right? And this is one of the things I get involved in out there. That's why one of the things I'm going over with you on here. All right? A lot of this end of this is a lot of bypass stuff.
You can wipe out an AC clutch if you hotwire the fan.
Oh yeah, absolutely.
Because you'll cycle it so much.
Yeah, absolutely, absolutely. So, like I said, they have timers available that can do this. They have all kinds of things out there. All right. Now I'm going to show you one thing about bypassing the power supply to the PCM controlled actuators for testing purposes. All right. Here's a car. Jerry and I worked on this car just a few days while I was making up the class. We took some pictures. We're just testing. We have an actuator down here. We have a valve down here, all right, and one of the emission valves, all right. We're just testing it right now for power, all right. And Jerry was saying, well, all right, let's test it, make sure it's got power. I may do this test for power, all right, but I like doing one other test too. If you've seen my last class that I had, I made myself up a high amp test light. My high amp test light was basically a fog light with an H3 bulb in it and test leads. All right? Because that's going to, at 12 point something volts, battery voltage, it's going to draw roughly, or very close to 5 amps. All right? I made myself a 5 amp test light. All right? With that. Now what I would do, I would ground the one side of the test light, and then I would touch over here, all right, and I'd make sure that I could pull 5 amps through that power. I'm sure that that lead probably has about at least a 10 amp fuse in it. All right? But the other thing is that we only had power there for so many seconds when you turn the key on. So we want to test the whole circuit and make sure that that actuator works. All right? So we don't have power there all the time. We can't plug it in because we don't have power there all the time. So what we're going to do is, with that connected, right, we could go to the wiring diagram and say, hey, let's look at the wiring diagram and see what pin it is at the PCM. Right? But then, who knows if the wiring diagram is right? I like to make sure. So I took the other end of that connector, the one that goes to the PCM, I put a wire tracer on it, and I found exactly what pin that goes to. Put a wire tracer on there, found exactly which pin it goes to. I don't have to even check the wiring diagram because that's the pin it goes to. All right? Now I can go and I can check that wire. I did it with my high amp load tester. All right? And I've checked that wire. The wirings, naturally this car was running and everything was fine. We checked everything was fine. All right? But what we're doing here now, we checked it with an ohm meter. Just wanted to make sure that it was fine. All right, this is all we did. I would do it with if I had to do it with this and I had any question about it, all right, I would do it, put that 5 amp load on it. All right, here's somebody was asking me before about amp clamps. All right, here is a multimeter and 2 different amp clamps. All right, they're both 0.7 something amps. And what we did here is, so that's 700 and something milliamps. They're all reading about the same, very close, should be virtually no difference. All right, here's that valve. We put power to that valve, all right, direct power, and ground through the multimeter leads, and then we stuck the multimeter leads through the amp clamps. So we're just testing to see, make sure how accurate these things are. Very accurate, all right? So you could, if you have a small wire and you only have one of these, that's fine. But if you have big wires, you want to put battery cables through something and test for battery drains or something like that, all right? You need a meter with a larger hole in it, like that, okay? So we were testing this for current draw, all right? And it was drawing 770, 90 milliamps, all right? 7 point something milliamps. 700 and something milliamps, excuse me. Close to it. Close to it. Close to it. All right? So, in any case, we checked, that's how we would check the wire. We put power to it and we grounded it through that circuit. All right? We put direct power to it. All right? I got a complaint. Now we're going to some case studies here. Customer here's arcing under a hood of the car. Customers. Now I'm not talking about my customer. I'm talking about my customer's customer. All right. The owner of the car reports to the shop, I hear arcing under the hood like I have a spark plug wire shorting out. All right. There's a popping in the radio. The check engine light is going on and off. And what we'll see in a minute, it may have burned out one of the computers. The shop checked all grounds. They were okay. He checked at first all the ignition circuits and components. They were okay. But then he decided to start changing grounds. He changed the coils. He changed the crank sensor. He changed all kinds of things. As I said, he may have burned out the PCM. 3 things burn out PCMs. 1, overcurrent, but not much anymore because most of the current computers take current, overcurrent in stride. They're almost burnout proof as far as overcurrent goes because they'll even tell you a circuit is shorted, right? They'll tell you that. All right? It knows it's shorted. It shuts it down instead of just burning up. All right? But spikes and polarity are the biggest things that cause burnouts on computers today. Voltage spikes. For example, you take out of a car a guy's old remote start system, an old alarm, and you save all the components, especially the Bosch-style relays and that sort of stuff. And you stick that in a car that has you say, hey, I got one of these relays around, and you stick that in a car, all right, that uses a Bosch configuration relay, the 5 or 4 pin relay, right? And you don't realize that none of these aftermarket components use spike suppression on their relays or inside their relays. And every component, every relay in a car has spike suppression. If you don't have spike suppression, that computer can be burned out. If you don't use proper spike suppression. All right? And polarity, of course, somebody reversing polarity, whether jumping a car, hooking up a battery, or anything else, that's the other big burnout on computers. All right? Those are the two main things for burning out computers. But he says this computer burned out due to spiking, high voltage. He hears arcing. But he doesn't have a miss in the car at all, except for a flutter here and there, but no miss. And then when he hears the fluttering, the check engine light comes on. And then it'll go off and everything will stop. But he can still hear this arcing. Then he shows me what he found. He pulled the right front tire off the car and he says, I see the crankshaft pulley like this on the car. All right? He says, after the customer told me all of this, he says, I see the crankshaft pulley. Now, this is not the crankshaft pulley of the car. This is another crankshaft pulley, all right, that we have a picture of here, all right? And this has a metal case around it, all right? But the other car had a plastic timing case cover with studs or bolts here, had 3 or 4 bolts here or there on both sides, and it was plastic. And behind that plastic cover was the crank sensor. And he said, now I want you to watch this. And he started the car up, and as he brought the engine up in RPM, all right, you start hearing these sparks, and you look and you see right across from the crankshaft pulley, right across the plastic to each stud, there was arcing to every stud across there. And this is what I was seeing. He showed me. You had arcing coming out, going across the plastic towards these studs. And it was also going through the plastic at some point, getting to that crankshaft sensor. And I think that's probably what may have burned out that one computer. That spiking. Now, the other thing I found, and this may start giving you a hint. You got any hints so far, anybody? What might be causing this? Why is the spark leaking out from the crankshaft? Bad grounds, yes. That's what I figured too at first. I'm thinking bad ground. Anything else? They were saying bad grounds on the coils, something like this here. All right? All right. Let me tell you the next thing I noticed on this car. The next thing I noticed is that, first of all, the belt was extremely tight and it was completely covered. All right? The belt, the pulleys, everything were completely saturated with belt dressing. Complete. I mean, there was so, it must have used a whole can of belt dressing on this car. All right?
Trying to get rid of the arcing.
Not to try to get rid of the arcing, all right? What?
Was it transmitting electricity from the alternator?
No. All right. I figured that when I told people about the belt dressing, I had somebody get it last night. All right, one person got it last night.
Static electricity?
All right, static electricity. All right, static electricity. All right, from what? All right, and friction is due to static electricity. All right, here's what was happening. The guy was hearing a belt squeal. That's why he tightened the heck out of the belt and sprayed so much stuff. He's hearing a belt squeal, but it wasn't a belt squeal. The rubber inside between the pulleys, okay, rubber inside between the pulleys, all right, had come apart, all right, and it was turning.
You made it separate.
And just like taking a balloon and going like this or something on you and developing or rubbing on the rug or something with your feet, the static electricity was being generated, and the tighter the belt was, you got to remember something. The harder you rub things together, the more electrons you're going to rub off. And at high speeds, this thing was jumping sparks all over the freaking place. All right? So the fix on this thing, and I told him, I said, the fix on this thing, all right, was to put naturally a new crank pulley on, all right, and a new belt, I said, because that belt is and clean the living daylights. Get all that freaking belt dressing off there. Clean up the mess, all right. And of course that solved his problem, and there was no more arcing, and he wasn't afraid of burning anything out anymore. All right. So, but that settled that on that. But and I'm going to tell you the first thing that gave me the clue. All right, what was happening there is while I was making ground tests, I was touching, naturally I took the test light, put it on positive, and I'm taking the tip, and I went down to the crankshaft, and I said, geez, it's grounded, all right? And as I came up, I happened to touch the tip, and I'm saying, wait a minute, that's not grounded. And I said, oh, can't be grounded because it's got the rubber, And I said, oh, wait a minute now. I said, yeah, the rubber in between there, the two parts of the pulley there, and I said, that's what's going on, and that's what gave me the idea of what was happening there, all right? All right, here's another complaint, all right? And now I'm giving you universal complaints. That's why I'm not telling you specific cars, because this can happen to almost any car.
What car was that with?
It was a Toyota, all right? And, but I'm not going to give you a specific car because this can happen to any car, all right? Here's a complaint. I have no communication. I have a no start condition, and I have no 5-volt reference. All right? What's the first thing you're going to check if you have no communication and no 5-volt reference? You may not have a no. If you don't have any of those, you probably don't have a start anyway. All right? All right. You're going to check fuses. You're going to check power to the computer. All right? All right? But as far as the 5-volt reference goes, all right, that's something that can give you a hint. Now, take a Chrysler product with a shorted crank sensor. Very common problem, right? Right? Takes down the 5-volt circuit, right? How can you check without, if you've got a car that you say, well, I want to check that 5-volt reference. Do I have 5 volts and it's being shorted out? Or to ground, or is it not generating 5 volts? So let's go there first, all right? All right, now, there's your amp clamp. There's your amp clamp, right? Now, I want to check the amperage on that 5-volt circuit the second I turn the key on. Why? People say to me, there's no amperage in there. How can you check it with an amp clamp? Well, you're right. You're absolutely right. Because the average sensor is between 4 and 11,000 ohms. Even at 4,000 ohms, you put your 5-volt reference in there. At 4,000 ohms, you're talking about 1.25 milliamps. You can't test 1 milliamp with these testers. You really can't even test it with a multimeter. 1.25 milliamps. You can barely test it. And if your sensor's up at 11K or something around there, you're going to draw down about 1/2 of a milliamp.
But if it's shorted.
All right? If it's shorted, though, the second you turn that key on, all right, these 5-volt regulators inside the PCM are capable of putting out up to 1 amp. But they are short circuit protected, all right? But the second you turn that key on, that amperage will jump up and then it'll shut it down. All right? If it's shorted. All right? So I'm just testing to make sure I don't have a shorted 5-volt circuit, right? I did not. As a matter of fact, I saw nothing. I saw no voltage at all on the circuit, and I saw there's no amperage coming out on initial key on. Now I definitely go to powers and grounds. I had ignition. I had all the grounds were fine. All right. The memory circuit to the computer, the 12-volt constant power, was not there. What did I do? I went to the PC. I hooked up my tracer. All right. And I looked at the wiring diagram. It came from the battery in the trunk and the power supply in the trunk, all the way from the trunk through the front of the car to there. All right. So I decided to break out my tracer. All right. Now, if you look at the bottom picture, this is how I had to hook up the tracer. I took the transmitter. I pulled the fuse out where it was. All right. I put the transmitter on that part of the fuse. I went to the PCM. I disconnected it, but at this point you may not have had to. I grounded the wire at the PCM. There's a reason for that. And I explained it the last class, all right? And that is that if there's a break in there, and the break is not whole and complete, it's not like you saw the break in the wire where they were hanging down like this before. It's close. It's the plastic is holding it together. It's corroded. All right. The frequencies generated by these transmitter can actually not arc, but transmit and jump across the circuit. And if I had no ground here or no load here, and I was tracing this wire with the tracer, the pickup end, it may just trace from one end to the other and say, hey, I've got no problem. But if I ground this end, that means that this whole wire on the other side of the break has got ground on it. It'll ground out the signal as soon as it passes the break. And when I trace it, I will trace it right to where the break is, and the signal will stop. Everybody get that? What I found on this car, have to be a Chrysler product. What I found in this car is behind the glove box, there was a connector that was together on a little bit of an angle. It wasn't really connected good, all right? So I just pulled the connector apart, made sure I had power there. I did. They looked good. I connected it good together and made sure it snapped and locked, all right? Had no problem. Everything came back on the car, and the car started fine. And it ran fine, and all my circuits were back online. All right? Another complaint. This is an intermittent problem. It's Basil's problem. All right?
Figure this out. 3 days. This is why I called Rich.
All right.
This one kicked my ass.
Intermittent problem. The ABS lamp came on. The brake lamp came on. The speedometer drops to 0. No communication with the ABS module, and no upshift. All right? And it all happens instantaneously at once. No.
05 Dodge Ram 2500 pickup truck.
All right.
They did it intermittently. So
Yeah.
sometimes it would be perfect.
Yeah.
And then other times, that's what happened.
All right. So that's what was going on. That's what was going on. So I went over there, and at first Basil couldn't get it to do it. He took it out on the road when I got there, and it wouldn't do it. It wouldn't do it. It came back to the shop, and I think it did it one time for a short period of time, and then it just cleared up again. So then we went out on the road. I took my scan tool, and I graphed the vehicle speed. I graphed the vehicle speed, and we drove it for a while. And all of a sudden, and it was fine, all of a sudden, everything happened at once, and I saw the vehicle speed completely drop out, instantaneously, just a drop out. Now, if it was a vehicle speed sensor problem or a connection problem in the vehicle speed sensor or something like that, I probably would have seen a lot of hashing, and problems and then going down to nothing. But a complete dropout to me meant that the ABS module, again, was completely, either something was wrong with the module, we were dropping out because everything was dropping out, or it was a power and ground problem. So we went out, and we had checked this earlier. I did its power and ground test, and it was fine. Went back out to the ABS module. This time, now that the problem exists, ABS module had no power. Went to the wiring diagram. I said, let's see where it gets its power from. It gets its power from a specific fuse. I took the cover with the little screw off the fuse block. All right, that's where I was saying I was just measuring power, and I had no power, but this is what I found at the fuse block. Those aftermarket fuse adapters in the fuse block, where you take it out, and these are the better ones, though, not that you take the thing out and you can put two fuses in, one for the, I always recommend you use those if you're going to tap, all right? But this happened to be a real cheap one that somebody used, all right, wasn't very good, all right? And I said, Basil, watch the light. Because I had the light, the drop light, a test light rather, on that wire at the ABS module. All I did was touch my finger on the top of that, and the light came on. All right? And that was because the two little terminals that come out of it going to the fuse holder, all right, weren't heavy enough for this particular fuse block. They were very thin, and they weren't making good contact. So what I had to do on this thing, I said, I'm not going to mess around because it's the ABS module, all right? I took this out of there, all right? I put the original fuse back in, which made it fine, all right? And I took this module. There was an empty relay slot in the power distribution block that did have power on one terminal, all right? And they weren't using it for anything, all right? And this is the fuse. I can go whether that's fused or not doesn't bother me, because now I can, this is fused, and it was a low amp fuse. That was fused. So I just bent one of the pins up, so I just had one pin sticking out, all right? And I connected it onto that. And I made it so that it made a good connection on that. All right, so I still gave the guy an aftermarket power supply, all right? And I put the original fuse back in the fuse box. That solved the problem.
Wait, can I add something to this?
You can add something.
The whole problem with this truck, when it started, we had a bad vehicle speed sensor, which according to the dealer, the vehicle speed sensor is in the rear differential. When I pulled it out, it was broken. When I called Mike from Cedar Grove Trans over here, and I looked at the wiring diagram, the speedometer runs off the output shaft speed sensor on the transmission. That was also cracked when I took it out. Plus, we found the two bad connections on those, and the 4 chafed wires on the top of the transfer case. 3 days. I wanted to light the truck on fire.
Now they found out that before I looked at the vehicle.
I got it. Before I got to the point where I couldn't take it anymore. And then I called Rich. Because I mean, like I said, 3 days working on this thing, I wanted to choke everybody. But it was to a point where I just couldn't trace anywhere. I couldn't go anywhere. And that's why I called him. And it worked. And I mean, but we spent how many hours that day doing it?
Yeah, well, only because you couldn't get it to do it.
Yeah, that's it. It was intermittent.
Because you couldn't get it to do
We were
it.
ready to give up, and we were just pulling into the shop, and that's when it died, they crapped out on us.
Right.
And here we are on the side of the road with a scanner and test lights trying to figure it out on the side of the street. But
And sometimes that's what it takes. It takes, you have to get it to do it. You have to get it to do it. All right. You don't want, if you let it go and it goes on the customer and he has to get towed in again or whatever, it doesn't look too good, right? Okay. Let's talk about some power window bypassing systems that are out there. All right. Again, used car lots. A lot of people with older cars, and even some of the newer cars, used car lots don't want to spend a lot of money fixing stuff. All right. I had a Cadillac a few weeks ago that had a bad power window system. All right, the power window door switch was bad. $980 for a power window switch from Cadillac. All right, the guy says to me, "What can you do?"
Best of all, it's a Cadillac.
Guy says, "What can you do?" Well, you can always do something. All right, but still, this is what's happening out there. All right, you're getting some cars that they don't have to make parts for cars that are more than 10 years old. All right? They don't have to. Excuse me?
They cut it off at 7.
Sometimes. Oh yeah. So yeah, sometimes. But a lot of times it's 10 years old is one of the standards. All right. So if you have a car that's older than that and it's a good car, low mileage, and you've got to fix something and parts aren't available, what do? All right. If you're going to bypass something, bypass it right. Okay? If you're going to bypass something, bypass it right. All right? Now, here's a bypass that you can do. This is a Ford, happens to be a Ford. This is what they use for their automatic down. A lot of people tell me that the driver's window, because it gets used the most, and they have the automatic down on Ford products. Not only Ford products, but on this just happens to be the one. All right? They run the automatic down through the BCM. All right? And or front control module, whatever they call it. It's one of the body modules, all right? And they have, regular switches, all right? But they have it going through the BCM, which runs the, and if that goes bad, the windows won't operate at all. The driver's window won't operate at all, all right? But rather than replacing the BCM, all right, if you tell the customer, look, I can fix it, I can get it to work, but you're not going to have automatic down. All right? Very, very, very simple. Cut those 2 wires off the BCM and connect them together. Take them off the BCM, just connect them together. You'll have up, down, just not automatic. That's all there is to it. That's all there is to it on that system. Now, some of the systems, you really can't get around the electronics, although they do make some electronic bypasses, solid-state bypasses that can take into consideration the low voltage inputs from different things, all right? Sometimes I stay away from them, all right? If you really need to get involved in something, all right, there's another bypass available, all right? There's a kit. All right, if it's a completely solid-state circuit, all right, no matter what solid-state circuit it is, you've got to have main power and ground going in if you've got main power and motor power and ground going out. All right, so this system just ties into the main power and ground with 2 wires and hooks up to the motor with 2 wires. The whole system, all right? And then it gives you a very small little toggle switch, all right, that mounts in a 1/4-inch hole, very tiny, all right, that has an up and a down. It's a single pole, double throw switch, all right? You can mount next to the other switch, all right? And the only thing you have to do besides tying into power and ground and putting it across the motor is cut the 2 wires that go to the motor from that module, all right, and, just tie them off. Cut them off of there. That's all you have to do, all right? Now, if you put these wires on one way or the other, it doesn't make any difference because the switch just goes on with a little hole. The drill, just turn it one way or the other way, and it'll be up one way and down the other way. All right? Very, very simple. These things are all available. All right? Any questions? Daytime running lights and problems related. All right? The older cars at one point used to do one thing to give you daytime running lights. They would either put the lights in parallel or series circuit. If they put them in series, B plus on one light, through that light, through the other light, and then to ground, the light power would be cut in half on each light, all right? And you'd just lower the lights would be dim. And then to put them on normal, they just put them back in parallel circuit again. All right? Some of the, especially GM, at one point, what they were doing is putting resistors in between each light. Now what they do with the module or computer control lights is, again, go back to pulse width modulation, a chopper circuit. All right? They want to vary, they may not necessarily vary the intensity of the light, but they might want a specific set point, so they would give a specific pulse width modulation to the lights. All right? And to monitor each lamp, they control each lamp separately. That gives them the ability to tell the computer, hey, you've got a light out. All right? So they feed each lamp separately with power and ground them separately through a module of some sort. And for daytime running lights, which is usually just the high beams, all right, for daytime running lights, all right, they use, again, a chopper circuit. Now, go to your regular lights, your normal or low beam lights, and I get this all the time. Something happened, we got a light out. All right? Put a new bulb in, and they find that the light's still out. They check it, it's got power there, power here on the other side. The other side's working fine. Got power all the way through. That means that this module is not grounding that circuit. All right? Now, rather than replacing this module, what do most shops do or to get around this? Ground the one that it goes, right? Run a jumper over there, right? Okay? Very common problem. You see, I see it all the time. And then what happens, maybe a month down the road or a few weeks, depending on how often or how much the guy uses the lights, all right? Being the fact that this module now is grounding this light and grounding that light, all right? That module burns out. It overloads the module, all right? So, again, when I told you as far as bypassing, there are things you can do. Let's do the right thing. Take a little relay. Again, Bosch type relay, but whatever you do, make sure you have a relay that has spike suppression in it. I show the coil and I show the spike suppressor across the coil. All right? Now all you're doing here is you're going to ground this wire. You're going to ground this wire through the relay. The relay is going to ground that wire. And all you're going to do is finish the circuit here. All right? All you're going to do is put power from, it could be either side, as long as you have power there, to the relay coil. So when the, there, and when this side gets grounded, you're pulling just a very minute amount of power to power up the coil. But remember, this is sensitive here. It's grounding a resistive circuit that has no spike in it when it shuts on and off. So it doesn't need spike suppression. But here, this is a coil that'll give you a spike. Again, spike suppressor. You can see if you look at the relay whether it has a spike suppressor on the relay or not. It should have the coil and then another piece down below it. It shows a spike suppressor. All right, the other side the other side gets grounded. When this gets grounded, activates the relay, turns that light on. All right, easy bypass. Easy bypass. All right. Now, let me get into using an external driver module. Everybody knows what a quad driver is. Is an output circuit from a computer. It can supply either a positive signal out or a ground signal out. It can drive an injector. It can drive a relay like a fuel pump relay or anything. All right, anything up to its capability. Its usual 1 amp capability. All right. Now let's say this is a computer. Let's say it's a GM computer, and you're sending a signal out here to the relay, fuel pump relay. All right? So it would send a signal out to the relay and then to ground through the coil. All right? And somebody went out there because the fuel pump's bad, but they want to test it, and they go out there and they accidentally, during trying to crank the car or whatever, or they accidentally put a jumper from the positive to either ground or to the fuel pump out wire. All right? And you try cranking that car and burn out that quad driver in the PCM. If that happens, many times when they burn out, they don't necessarily burn out all the way. All right? So if you cut this wire, for example, here now, and you say, well, it's burned out, I got to replace the PCM. You don't really want to replace the PCM if you don't have to. All right? If you can find, when you turn the key on, usually it's only 3 seconds at first when you turn the key on, but if you can find at least a 3-volt reference voltage, it may be, if you hook this up to the normal relay, you may get 0 there. All right? But if you cut that wire and you get a 3-volt differential between ground or positive, it doesn't make any difference. All right? As long as you can get a 3-volt differential, you can turn on a driver module circuit. Driver module circuit has a trigger side and a load side. All right? If this is, and it can work on a positive. You can feed it positive or you can feed it negative, and you can put out a positive or you can put out a negative with all the same, with the same module. All you need is 3 volts here to trigger it. If you find you get a 3-volt or more signal here, you can trigger this circuit right here. Put the negative to ground. Put a positive on the load side. Put a positive source here. All right, fused, and then you can trigger. This will do your triggering for you to the relay.
Transistor relay, like a PNP or an NPN?
A transistor relay.
You could use like an NPN, would be fused negative, or PNP.
You mean in place of an external driver module? It's possible, all right, but you'd have to put some other circuitry in there.
Ground or hot to trigger it.
Yeah. You'd have to put some other circuitry in there, though. All right, and if you have a grounding circuit, the same thing. You'd have positive at the relay and a grounding circuit. All right, same module, just hooked up differently. You'd put positive to that, a fused positive to that, ground there. Well, this will give it the ground, as long as you have at least a 3-volt reference there. All right. This will go to the output and will ground that and trigger it. All right. And this will take up to 2 amps. So you'll actually double the load capacity of it. All right. This works on a lot of different things. I've used these things all the time, and they work phenomenal. And you don't have to put any other circuitry in. You don't have to put resistors in. You don't have to cut the load down on anything. All right. So these things work fine. These things work fine. All right. Any questions on it? Last slide, guys. Then we're out of here. All right. Quirks on LEDs and HIDs. A lot of guys are putting LED lights in cars today. There's some things that you cannot use regular LED lights on because certain vehicles require the load of the current, small currents passing through the filaments of the bulbs to detect certain things. I'll give you brake lights, for example. Okay? Brake lights, for example. However, there are LED lights that can handle that. They have a load, a slight load across it. All right? Now, the other way of getting around it is people are putting actual resistors that take the load across the LED. Now, you still get the benefits of the fast on the LED, which looks nice, all right? Still get the benefits of it. But if you're using the LED lights to actually cut down the load, all right, it doesn't work, because if you're using the resistor across it, you're still giving the same load. Okay? All right? So that's one quirk. And they do these things. They do have also some of these things, if you use LED lights, will turn on your lamp indicators, your lamp out indicators. Again, they do have some lights, I think some of them are called CAN bus lights, all right? And what they'll do is they have a capacitor across the load. And sometimes the computers in the cars or the modules only test for a split second when the light comes on. So if the capacitor charges up in the circuit, all right, it'll say, okay, it went on, I had a load for that, and then it's all right. You know, it'll only test the second you turn the light on. I'm saying some of them, all right? So just watch it on that. One other thing with LED lights. If you're using a light in the tail, as a tail light, an LED light is a tail light, all right? Everybody knows, all right, they use, LEDs are available in different colors, all right? And if you're going to replace a tail light, everybody puts a clear bulb in it, all right? So everybody gets a clear white LED. A clear white LED, just like a white bulb, puts out all colors. The lens filters out the red and only allows red light through. LED the same way. But an LED you can buy in red that only puts out red light. So why put a white LED in where you still have to filter out some of that light with the lens? If you put a red LED in, it only puts out light of red wavelength. Therefore, it will actually look brighter with a red LED in than it will with a white LED in. All right? So if you're putting in taillights, all right, that go through a red lens, use a red LED. All right? Let's get into HIDs. HIDs. All right? A lot of guys are putting HIDs in today. All right? Kits. All right? HID kits. All right? Again, if you put them in the high beams, where the cars are using pulse width modulation to lower the voltage on the high beams, again, it's modulating. It's on and off, all right? And a lot of these cars, when they put these things in, are blinking, those LEDs, HIDs. They actually start blinking. Again, they have a fixed kit for it. Again, it's a capacitor that goes in the system and just plugs in to the power supply, and it quelches those blinking, all right, LEDs. All right, there's a little kit that goes in. All right. Another thing with LEDs, HIDs, excuse me, HIDs, is that there has been some talk about outlawing some of these HIDs. All right. The main reason why, if you look at a factory HID is, if you want to call it, squelched, all right? They actually because of the lenses, they bring them down, they concentrate the light, all right? They're not just all over the place. You put in aftermarket LEDs and it's just floods everything with light, all right? And I'm sure you've noticed people with HID lights on cars that are coming at you all right, with aftermarket HID lights on, and they are very, very, they just got way too much light. You'd think their bright lights are on plus, all right? And I know I have my son has them on his truck, all right? And he has not only the HIDs on his low beams, he's got them on his high beams, and he's got them on his fog lights. And every time he's got the low beams on, he's always got his fog lights on. And he comes down the road, and I have to shield my eyes.
Backup lights.
Excuse me?
Have a customer put them in his backup.
That's fine. That's fine. That's fine. That's great. All you have to know is all you have to do is have a socket that can handle it. You can put them in there. There's no problem. There's no problem. All right. Any questions on any? Yeah, go ahead.
Question that I never found a solution for. With HID, with a factory HID system,
A factory HID.
how can you tell if you have a bad ballast or a bad bulb without swapping bolts over? Is there a way?
Is there a way? Well, naturally, you're going to check for power and power consumption. See if the power is being consumed by the ballast. All right? Even the people who are really involved with them, all right, usually will try a bulb. All right? And checking the ballast for current flow. All right? That's the two basic ways of doing it. Because if the ballast is pulling current, and a lot of times, sometimes you can actually listen to them and hear them.
Sometimes when a bulb is going bad, the ballast will try to rapidly refire.
Absolutely.
Rapid
Correct.
blinking.
Correct. And just be careful of connections, because a lot of bad connections on that. All right? But, yeah, as far as the bulb goes, the only thing you do is replace a bulb. It's that simple, you know what I mean? And, ballast, they have today now, there are universal ballasts that you can put in place of the factory ballasts with no problem.
One other question, like say on
Go ahead.
the power window switches, right? Like
Power
I had
windows.
Blazer the other day.
Right.
Now you buy a new switch, it won't work unless you get a program.
That happens, absolutely.
Why are they doing it? You know, I mean,
Less parts on the shelf.
Well, yeah, all right. And of course you have to remember something. It's more and more programming. The dealer wants to get involved in every aspect of that car. All right? Dealer wants to get involved in every aspect of that car.
Actually, LED lights, LED brake lights.
Right.
I haven't seen it, everybody always tells me about it, but maybe you ask if you've seen it and can explain it. They put an LED light bulb and brake light on a Ford pickup,
Right.
Ford truck.
Ford.
You don't get the torque converter.
Right. You don't get locked up and things.
Right. What caused that? Just to change the resistance? It doesn't.
Well, no. What's happening is the computer is actually looking for a ground. It wants to know whether the tail lights the stop lights are on or off.
Right.
All right. And what's happening is that, what it's looking for, instead of watching for voltage, all right, coming into it for the stoplights on, what it's doing is sending out a small voltage, a reference voltage, and watching for the ground so that it's off. And when the lights are on, that ground is not there.
Okay.
All right? That's what it's doing. It's exactly what it's doing. Any other questions, guys? All right? If not, that's it. We're done. Okay?